sediment basins, it's most important to get the information from boreholes. Yeah, there you normally have quite flat areas. Sometimes, if I think of India and the Ganga plains, there we have it is only a few tens of meters above sea level, and a very flat area, not a lot of hills, where you can also measure structures in the geology and so on. And therefore, the boreholes are very important here. Yeah. So at this point, we solve the problems of regionalization in another way. That means if we have boreholes, borehole information, then of course we will try, as we learned it as geologists, we will try to connect certain parts of the boreholes with each other over long distances. This is dangerous. It may be that a certain geological layer doesn't go from one borehole to the next just straight through. This is normally the case, especially in the glacial sediments here in Europe or in Northern Europe. Therefore, but also in fluvial settings, this is quite tricky, and it is not always correct. Yeah. So be careful with this. We have to, use sometimes even. Was there a question? Mrs. Sri Shalini. I don't see the name here completely. Satyanaran. Is there a question? No. Okay. Especially in the glacial series here in Northern Europe, it is tricky to work on the one hand with geostatistical methods, and on the other hand with cross sections and the generation of the outline of tills and so on. You have to obey a lot sedimentological parameters too, besides the hydrogeology, of course, and the geology, the general geology. Okay, on the other hand, the regionalization of the hydraulic conductivity is a little bit tricky. I mentioned this yesterday already, because this is normally not normally distributed. It is skewed to a certain extent, and then you have to use this these logarithmized values, as I told you yesterday. Yeah, if you logarithmize, which is quite easy to handle, don't forget to delogarithmize, this is clear. And once again, there are three advantages that you have with logarithmization. On the one hand, the formal, the mathematical background that you will not get an undershooting below 0. But the second thing is that is also more or less mathematics. It's a statistical question. With the skewness, you get better normal distributions in your logarithmized data set. And the third thing is that this meets also our field experience a little bit better. Of course, we know in the background we have our Darcy, our law, or we have Darcy's law, which is linear and not logarithmic. So it should be always a good idea to test it, to look for it, if this is suitable, if this fits to your experience about the area, and this cannot be generalized for all of your hydrogeological projects. So especially if you go to the yield, but also if you look for the transmissivities, then you have to integrate over the depth. This sometimes makes it more easy, but sometimes it is not the best way or not what you want to. If you look, for instance, for certain distributions of contaminants at contaminated sites and so on. Yeah, the last thing we can give away. We come back to this tomorrow. The atlases, the large-scale maps that we have, and the small-scale maps that we have. We come to this tomorrow. So some of the parameter maps, but this is no good, no good figure here, of course. This is the project that is going on by now in Germany. So we by now set up our 1 to 50,000 hydrogeological maps. Also this will be mentioned tomorrow. So the 1 to 200,000, so the medium scale maps are already finished, and by now the federal states come to the 1 to 50,000 maps. For the former GDR, this is a little bit better, or they have an advantage, because during GDR times in the 1980s, the 1 to 50,000 was finished, but on a level that may not fit to the systematical approach that we have by now in the Western federal states. So this will take a little bit of time, and we will see what is coming out. You can see some results already in the internet, because most of the maps that are produced by now, also the hydrogeological maps, are produced digitally, and therefore they are published also digitally and not any longer in analogous form. Yeah. But the 1 to 50,000 of the former GDR, these parameter maps are analogous maps, and you see one here. It's, yeah, the scan is not so good. I'm sorry for this, but with the colors, it is a little bit tricky there. They are always yellow colors, a little bit green, but dark yellow, brighter light yellow, and some steps in between. And this leads me to the point, in a map you should not show for aerial distribution or for spatial distribution the more than 12 colors. Yeah, you cannot distinguish more than 12 colors in a map. If your legend is there and you have some points or some small area somewhere, even if you have it in blue, green, red, and in between some colors, you will not get the color from the left upper left side, from some polygon there to the legend. It is difficult. Yeah, it may be 20 colors, but not really, not more. The rule of thumb of 12 colors is quite good. Yeah. And this is a little bit tricky here if you only have one color in the end, and different levels of depth here. And so these are in the end the structures that are given here in colors. That means the thickness in this case of the aquifers, and you see there some small in rectangles and with numbers in it. These are the estimated hydraulic conductivities, and you see on the other hand some brownish squares with numbers in it, and these are the connections between the aquifers. So the former GDR had a lot of glacial sediments, and they had a strict systematic for the aquifers in these glacial sediments, and therefore also the maps are on this level. So they have, for instance, for the last glacial, they have a map with parameters, with connections to the next aquifers and so on. Then they have from the second last glacial the same, and for the third, for the first glacial, they have it also, and they have the quaternary base and the tertiary then. So for each horizon they have a distinct and different map, and therefore you will find the connections also in the next aquifers that are summarized here in these maps for one map sheet, for one area. So down here you see also a little bit the legend with the colors. You see here the colors of the thickness. They are these are only ranges of thickness, not exact thicknesses with isolines. The isolines that you see here are the isolines of the pressure of the groundwater. It may be that the pressure, or normally the pressure is on a higher level than the top of the aquifer, so they are confined, and they are therefore, or it is necessary therefore, for different aquifers to outline here the flow conditions by these isolines here. Yeah. So this is a little bit about this. Yeah, the deficiency is, of course, these maps are very old. Okay. Any questions about this? I hope that from the slides with soundtrack yesterday in the afternoon, there are no questions about the vulnerability. It is a big topic, of course, but on the other hand, the concepts are quite elaborated, and therefore they can be described also quite good. But if you want to create such a map, you have to go more into detail, and it is a lot of understanding necessary between different disciplines, between different authorities and administrations to get such a to get the setup of such an interesting map as the groundwater vulnerability. With the groundwater parameters, on the other hand, you are normally quite free to do scientifically, on a scientifically high level, whatever you want. No, this is not correct, but it is not so obeyed by politicians as the vulnerability map, especially. Because with the vulnerability map, of course, you have the connection to contaminated sites, to contaminations in general, to agriculture, and therefore this is of societal interest, these vulnerability maps, whereas hydraulic parameters like the hydraulic conductivity or the structures, they are not of so high political interest. This is perhaps also the reason why we have so many concepts here. But on the other hand, due to the wide range of input parameters, we have also the necessity to have different concepts, for instance, for calcified systems and for these intergranular flow in unconsolidated rocks, completely different from fissured systems, and this makes it a little bit tricky here, with the groundwater vulnerability maps. Okay, but if you have no questions anymore to the about the hydraulic parameters, then we'll go to the maps of groundwater hydrochemistry. On the one hand, you are experienced with this, at least the Berlin students. But I think also, can you give a feedback a little bit from India? If you have also some knowledge about, or if you heard, for instance, a lecture about hydrochemistry, groundwater hydrochemistry, do you have this in Chennai in your university, or is this a complete new field for you?
If I may, Professor Gossel, I don't think we have some input from the university. Just a background here, we have students from two different backgrounds, one from the Department of Geology and from the Center for Climate Change. So the students from the Department of Geology have some existing knowledge on groundwater hydrochemistry, but not all students from the Climate Change department would have an understanding on groundwater hydrochemistry.
Thank you, Brenda.
I hope I am correct.
Yeah. Thank you. It helps a lot for me. Perhaps I should have asked already on Monday for this, but I think for both groups, it was hopefully an interesting lecture now. But for the geology, the afternoon will be very interesting with cross-section creation here in GIS. I think this will help them because normally the real modeling or the high sophisticated modeling tools are not available for the universities. I don't know how it is in India, but here in Germany, I know only a few universities who are capable of geological modeling and with the tools that are available on the market, but which are very, very expensive. So we will see about this in the afternoon, how we can work with GIS here. But on the other hand, the maps of groundwater hydrochemistry will lead also to topics that are going beyond the questions of hydrochemistry. They open new fields, especially in terms of the multivariate statistics combined with geostatistics. Because in hydrochemistry we have normally a lot of parameters. In hydraulic, for the hydraulic parameters, we have only a few of them. But of course, in hydrochemistry, we have a lot of them, all the organic contaminants, and on the other hand, the main components. All this is very interesting, and we will have we will look into some of the possibilities that we have there. In detail for the hydrochemistry, but on the other hand, this can be transferred also to other questions of parameter distributions and connections to multivariate statistics. Yeah. Okay, let's start. the first attempt to show hydrochemistry in a map is, of course, a very simple one. You can, I'll start with some maps, some examples here. For instance, you can show here organic parameters in one aquifer, the rules from yesterday for the outline of groundwater isolines. Of course, holds here also for the hydrochemistry. At the first attempt, it is good to show just in this case, contamination. This is Bitterfeld area. This means in Germany, a highly contaminated area with a lot of industry, a lot of contaminant input, especially with organic contaminants, but also some inorganic contaminants. And from this, you already get some overview. For instance, we have here also in our map not only the results from sampling and biochemical analysis for certain parameters, doesn't matter which parameters these are, but we have here also the sources of the contamination. That means former lignite mining areas where by now we have waste dumps, industrial waste dumps as well as household waste dumps, and therefore the combination of a lot of topics is the big advantage that we have in GIS if we work on a digital level. Yeah, we can also show here the groundwater flow directions via these isolines. We see by now, okay, this is going into this direction because here we have another lignite mining area. If you could read these numbers, then you would see it goes down here. The groundwater levels go down here. That means all the contaminants are dragged into this hole here, into this lignite mining area. And you may imagine that in former times where we had other lignite mining areas in operation, at these times we had also these big cones of depression in the groundwater levels, and therefore also the flow into the direction of these big mining areas. Yeah. So this helps already. Next slide gives a little bit more information on a process-based level. Yeah, here you see also the groundwater isolines, the same as the picture before, as the figure before. But here we are focusing on chlorinated hydrocarbons. That means these are special contaminants, especially here in this area, but they are widespread worldwide. And the question is by now, what do we learn for the processes, for the hydrochemical processes going on from such a map? This map is just the analysis result from the observation wells. We have taken samples, we have analyzed, and this is shown here in these small diagrams on top of the map. Yeah, this is in this case or something like this you can also produce in QGIS. Yeah, but we will not go into detail with this. The question behind it is more interesting for us as geoscientists. This map shows in the central part, and these gray areas here in this central part are really industrial areas. The colors show us that we have in the central parts more these purple colors, dark purple or light purple. And in the outer parts we have more the yellow substances. And we see by now also we see here also the isolines. So if I analyze this map, then I see, okay, these purple substances, they are in the central parts of my map. And spreading around this, we have the yellow ones. That means, if I look at the flow directions, and I have to take in mind they have changed over time. If I have in mind the flow directions, then I see, okay, there should be some metabolism coming from the purple substances and going to the yellow ones. So quite interesting that we can derive this already from this this picture here. Of course, there are some pathways where we have also high or a little bit more purple substances here, but mostly in the outer parts we have more the yellow ones. But the yellow ones are distributed also on the or are also flowing against the groundwater flow, because the groundwater flows in this direction. Yeah, it goes down here and even down here, and of course down here and here also down. Yeah. So also from this direction they flow into this hole here, but also in the northern part into the direction of this river which is flowing here. Yeah. But at some other time, we have in mind, okay, there was lignite mining in this area. We have, for instance, a lignite mining area here, and this means, okay, we had a drawdown over some time, perhaps a century ago. We had some groundwater flow from here to here, which is in this, in terms of this map of isolines, against the flow direction. Yeah. So by now we can interpret, we can go on in our interpretation. So we say, okay, we have some metabolism coming from these dark purple colors here, going through the light purple colors to the yellow ones. Yeah, and this is also the case here. We have a metabolization of the chlorinated hydrocarbons coming from the perchloroethene or tetrachloroethene, going via the trichloroethene and dichloroethene to the monochloroethene, and this is called vinyl chloride, and this is the yellow color. Yeah. The problem is that the biodegradation works quite well, and as long as we have, or in this, with these steps here, as long as we have the reducing conditions, and for the biodegradation of the monochloroethene, which means the vinyl chloride, we need oxidizing conditions. And this is a little bit a problem because in these areas you have a lot more contaminants than only these chlorinated hydrocarbons. And therefore, due to the biodegradation of all the other substances, you have always reducing conditions in the groundwater here, or here in this area, and therefore the vinyl chloride is not biodegraded anymore, because it needs oxidizing conditions, and only far away, when we have some more groundwater recharge with oxygen in the water and with perhaps also some nitrate in the water, then we get also the vinyl chloride biodegraded. Yeah. So this is quite an interesting interpretation with a very simple map that you can set up very simply here. Yeah. So, yeah, let's go back. Boom. So we see here, we saw on this last map how we can identify here the transport conditions and retardation conditions, metabolization conditions. Yeah, we see a lot already, and we can interpret sometimes really a lot. And you saw already, or you saw also that the groundwater isolines help also. That's what we have learned yesterday. Okay. Yeah. With the database management systems, we had this lecture on Monday. This is correct. And yeah, you remember this question of structured query language, ODBC interfaces, and so on. Yeah. Please, if you go on working in this field, especially the Germans, they are, or here in Germany, we work on our contaminated sites since the mid-1980s on a very sophisticated level, and we try to remediate these contaminated sites, and therefore a lot of students are up to now, up to year 2020, and with corona conditions, a lot of former students work in the field of contaminated sites. These are military contaminated sites, or contaminated sites by industry, or even by some waste disposals or whatever. Yeah, so this is a big topic. Of course, it's going down because a lot of contaminated sites are remediated or are handled, are treated in a certain way. But on the other hand, even up to now, a lot of students are working in this field. Therefore, this background is is quite important, I think. To know how to handle technically these database management systems, GIS systems, modeling systems, all these interfaces are quite interesting technically. Yeah, of course, most important for us, we are geoscientists, most important for us is not the techniques, but we have to learn the techniques to get our knowledge, to get more focused and to get to see what is going on there and to figure out the processes. So GeoDin database we have also seen already. Okay, in the GeoDin database it is possible also to hold chemical data. It is a very sophisticated tool, not only the geological data as we have seen it already, but also hydrochemical data, and you also can analyze on a good scientific level already the certain samples, combinations of samples also. So there are or paper diagrams available. There are genesis diagrams, hydrochemical genesis diagrams in it, and therefore a first analysis is possible also in GeoDin in terms of hydrochemistry. Okay, so if we want to calculate distribution of the hydrochemical parameters, then of course we should test first of all on normal distribution. If not, try the version with the logarithmization. Yeah, of course, then we need a variogram analysis, Krinking interpolation, just as we did it yesterday. Yeah. If we go to organic contaminants, which is mostly the case, the inorganic contaminants are quite rare, with some metals, trace metals, and so on. But for the organic contaminants, we have to regard a lot more parameters than just our variogram, of course. But also in the variograms, you sometimes see, for instance, if they if you take the directional variograms, which we didn't calculate yesterday because this is not feasible in GIS, but you may write, and you will see this also perhaps in the afternoon, you may write your own extensions in QGIS to get directional variograms. Yeah, we did it also in the course in the last year, and if you are interested in this, you can do this also in autumn this year, this gives you then already a first idea, the directional variograms of some retardation processes, of diffusion processes, of absorption, and especially or perhaps also metabolization processes going on, without having done anything, only the analysis, but anything in terms of process modeling in the laboratory. So you don't have to take the contaminants into the laboratory and do your experiments with this, with certain bacteria or whatever. But just from reading maps correctly and working good with these geostatistical methods, you can already get an idea what is going on in the underground. Yeah. This you saw this at the figure with the or at the map with the chlorinated hydrocarbons. Okay, we can interpolate. This is nice, but sometimes the results will not help us. And especially if you go to remedial sites, you have, or especially with a lot of contaminants, a site with a lot of contaminants, there you run into problems. Yeah, you have there a contamination with this, with these organics, there with these organics, there you have also a little bit of trace metals input, and what to do? How can we do this? Of course, we can overlay everything and we can create differentiated maps and so on. But we have a little bit a possibility, or we have more possibilities than just showing distributions. Yeah, and we will see this in terms of so-called indicator kriging. You see this here. Indicator kriging, which is very interesting in terms of multivariate statistics and multivariate geostatistics. Okay, yeah, points and maps. We have seen this PAH, VOC. This is always very interesting to see their behavior. How is the mobility in these soils that we have at this location? There may be completely different mobility in other soils and in other geological settings. Yeah. Therefore, it is always necessary to look at the sites in detail and not to have a general view on this. Okay, so this we had already. Okay, any questions about the theory background? We will come to the indicator maps or to the indicator kriging by now. I have prepared some data sets for you. In this case, they are fictive, but it doesn't matter. It helps us, on the other hand, very much to understand the general methods. Okay, no questions. Then we should start here with the dataset of Halle. It is not Halle. if you look at this in the on Google Earth or whatever, or some other maps, if you load just the background map from the OpenStreetMap project, then you will see it's a little bit shifted to the west, and on the other hand, I have shifted also some of the observation wells, so that the image that you get is a little bit closer to what we want to learn here. Yeah. Okay. So you find this in your data set under in the folder of fictive maps, and yeah, perhaps it's a good idea to get an introduction for today of these. Let me have a look if I have unzipped this already, or if I have to unzip it, or I don't think so. What's that? I have to unzip. Okay. So this is the hydrochemical map here of Halle, and we have also the lab for the pesticides and the nitrate. But these are only tables, so we have to get the tables running in GIS, transfer the tables to GIS. But on the other hand, you are used to this, and it's good to work on this question also here in the frame of the hydrochemistry to learn this here. So let's have first of all have a look at the hydrochemical data of Halle. So in the folder that I gave you on Monday already, you have these fictive distributions here. This fictive hydrochemical data. Okay, I say open hydrochemistry .shp, and I say add.
Right. I think you need to share the screen again.
Oh, yes, you're right. I have to start completely new. Okay. So sorry. Thank you very much. Of course, I have to share my screen. Okay, so starting QGIS. I think the first start in the morning of QGIS is a little bit takes a little bit more time. After that, or when you start it the second time, close it and start it the second time, then it's in the memory or already somewhere, and it's faster then. Okay, so hc.shp, hydrochemistry.shp, and this is in the case of hydrochemistry, or this is the extracted folder or the extracted zip of hydrochemistry Halle. I say open, I say add, and close, and if I get the background map, you remember from, when was it? Monday or Tuesday? Monday, I think. We get there by web and quick map services, and there we have the OpenStreetMap and OpenStreetMap standard, and it is not known here, sorry. HC or the hydrochemistry doesn't have a coordinate system here in the or fixed here. We have to set it, and we go to the layer CRS and set layer CRS, of course, and we have to do it. You see it already in the coordinates. We are in Germany zone 4 because this is the first digit here in the longitude. So we have to set, come on, for those who didn't do it up to now, the HDN in the filter, and then 3 degree Gauss-Krüger zone 4. Now I say OK, and I zoom to this again, or I set the project CRS from this layer, and I say OK, and perhaps it's a good idea to zoom to this layer. Then again, but no, it's gone. What's that? Hello? What's that? So once again, set layer CRS.
I got a warning, ungenaue Transformation von EPSG 4326 nach EPSG verwendet.
Ja, die Ungenauigkeit besteht im Millimeterbereich. Also die interessiert uns nicht weiter. So, yes, by now I have at least back my observation wells, and by now I have to set the layer CRS also to the project, and by now I can once again go to the web quick map services and load the OSM here and OSM standard, and by now you see Halle is here, and all the observation wells are a little bit to the west of Halle. Okay, so we have a look at the attribute table, and there you see, okay, we have several, these are the main components here. We have several ions. So bicarbonate, chloride, sulfate. These are already millimole equivalents. So this is already divided by the milligrams are already divided by the molar mass and multiplied by the loading? No. By the, yeah. What is this called? Loading? Ladung. Okay. So you have this here, and of course you can by now geostatistically interpolate based on these values the distribution here. But you see, these are a lot of parameters, yeah? And therefore it would be good that we use not only the geostatistical means, but also the multivariate statistics that we know already. Which multivariate statistics do you know? Which analysis methods in multivariate statistics do you know? Perhaps you have some, I'll make this a little bit smaller here. Some ideas about this. PCA, that's right. What else? Principal component and a tesseled cap. Interesting. It's okay, fine. Yeah, but the PCA already goes into the not only into the right direction, but also it is a very high sophisticated level or a quite sophisticated level. Of course, a correlation analysis between two parameters is already will be certainly the first step. But PCA is very, very helpful, and also afterwards the cluster analysis, especially if we look for clusters here of the observation wells which behave the same in the same way. Yeah. So first of all, let's do the principal component analysis. So you can take here your attribute table. You may click here in the upper left corner, and then you say copy, and then you can shift this to Excel, to any other, or copy this to another tool. Which tools do you use for instance, principal component analysis? R, very good. Very high level, very good. For the geologists, we have a very small tool. R is very complex, very big. So I think you can just save this as a CSV or Excel file then, and import this to R. This is no problem, and then you can work with this on the principal component analysis. Another tool that I prefer a little bit because it's not so big and not so complicated is PAST, P-A-S-T, Paleontological Statistics from the University of Oslo. It's also free, and it does what we want as geologists, but it does not more. So it is not as sophisticated as no, it's not there. I have it on my C drive. You don't have to install it even, you just copy it from the internet, and it comes as a zip file, you extract it, and it's an executable, and you run it. And then you can insert here, for instance, your values. In this case, I made a mistake because this first row should be. I run into a problem with this. So this should be deleted somehow. Okay. How can I do this? Cut. Yeah, it's possible like this. So this tool, let's have a look, multivariate, and I can do the principal component analysis here straightforward. I have to mark here, I think, all the columns and principal. Okay. Invalid value. Okay. I should have made it like this, that I created a new Excel file. Okay. I have to go back here to my. Where is my attribute table? It's gone. String copy. I find few. Okay. I will delete here this one. So perhaps it's a good idea to save this as a CSV file. Can I import here in past? Is it possible to import Excel files? Yeah, Excel files. So I save it as an Excel file. I save this as an Excel file. But not XLSX, but XLS, and this should be HC. Okay. I think I can open in past. No, I will open past again. Past for. Okay. Those who are fit in R are already finished. So this is in here.
Could you perhaps validate the official source for the past website software? Because it's not Windows supported, and I'm not sure if I downloaded it from the correct website.
Yeah.
Gave me a warning. I just didn't want to execute it before. Sorry.
Past for Oslo University and paleontological. Something like this, and you will get to the past for. So in this case, current version, no. It is a little bit tricky, yeah. Otherwise I give it around, it's no problem, I think. Is it here? Come on. No. Download past for Softpedia. That's strange. Past download here.
Please do not go on Softpedia. There are no
past download. This should then be a good idea. Yeah, you see it here. Past dot. I will just do it like this. String copy and oops.
To be fair, I think the first link seemed more secure from the History Museum, because this one you're posting now is just a repost from somebody.
Okay.
I think the first one I think is probably the right one. I just wanted to make sure because I didn't.
Yeah, it may be. Yeah, okay. No, it is not.
I put it in the chat. I'm pretty sure this one is the correct one now.
Yeah, this one, Natural Historic History Museum. Okay, this may be.
Well, because the other one is just some random guy saying, "Here, download this software," and we have no idea.
I think he's one of the main. I think he's one of the main developers, but I'm not sure about this.
Okay, well then that would be legit, obviously.
Okay, so downloads here. Yeah, okay. Okay, yeah, it's a very interesting software. On the one hand, for multivariate statistics, from my point of view, and on the other hand, in time series analysis. Yeah, it's very nice in time series analysis. It's really a marvelous software, and it's concentrating on topics that we as geologists, geoscientists normally want to work on. Okay, so by now I want to open my Excel file. Rows contain and columns contain names and data. Okay, and yeah, it's okay by this. Also, yeah, it's okay. Okay, then we should mark, in this case, the rows that we want to analyze. That means our main components. The cluster we leave away, and the XY coordinates are quite nice that we have them in the table, but of course we will not integrate them into our multivariate statistics, yeah. And then multivariate ordination PCA. And you see here, for instance, the scree plot. You find here the loadings plot, and this is perhaps most important. So in this case, we see bicarbonate, and in the first component, we see the sodium and bicarbonate. Difficult to interpret, but quite interesting. Let's have the correlations here. Now with the correlations, it works a little bit better. We have a lot of, or we have in the first component, a lot of parameters that have high loadings. Yeah, that means, yeah, it is bicarbonate, but with a lot of different cations here. And this is a little bit tricky. We have to interpret this. And this is our task, yeah. The technical task, okay, it's nice to see here that it works with this tool. And to see also what principal component analysis does. But the most important task is perhaps, or for us the most important task is of course the interpretation here. Yeah, the second component is here chloride and calcium and magnesium. Quite interesting to interpret. Yeah. And the third one is calcium dominated. Fourth one, sulfate dominated. Of course, if we look at the scree plot, then we see, yeah, okay, maximum 2 components should be regarded, perhaps the third one, but normally only 2 components, yeah. But we should perhaps interpret the others also, or it may be interesting to interpret this also. So here we have sulfate and potassium, calcium, magnesium, and to the opposite, the chloride is going is negative here. Yeah. Okay, so the first component, what is this? Oh, I have to shorten this a little bit to see questions. Paste. You meant this here, to paste here. Okay, thank you very much, Mr. Centric. This helps. So first component we saw. Oops, what's that? Where are my components? There. What is this? What is this? What are these waters standing for here? These analysis results, or these PCA results. If we interpret this water, what is this water? Bicarbonate with a lot of different cations, loading high. Seawater, well, I would expect from my observation, if I go to the sea, to the North Sea or to the Mediterranean or so, there is a lot of salt in it. Chloride, sodium chloride, and this is loading here on a very low level. Yeah, especially the chloride. This doesn't mean that we have high contents of bicarbonate. This is interesting. It hasn't got anything to do with the content, with the analysis result. It only analyzes which observation wells behave or have the same influencing factors, and it needn't be with a high content. What are these waters normally? Berlin students, you learn it with Andreas Winkler, of course. Perhaps even last week.
Well, I mean, it's a groundwater because of the high hydrocarbonate in it, and
as I said, it is not always high bicarbonate content.
High relation.
Yeah. That's right. That's the right formulation. Mm-hmm.
And it also means that we must be near neutral pH. It can't be too sour or too alkaline.
Yeah.
And I mean, we have a lot of magnesium, so maybe some dolomite. I don't know.
Yeah. But don't make the mistake with the content. Yeah. So if we look at this water, it has a high, or it is dominated on the anion side by bicarbonate. It means we have to look what is the genesis of this water, and the genesis of this water is, of course, it is not a chloride dominated and not sulfate dominated. And this means neither seawater, because this is normally chloride dominated, nor some gypsum water. This is, on the one hand, or this may be some water from limestone, but then calcium should have a much higher loading, and the others should go down, especially potassium and but also sodium. They should go down, and it should be dominated by calcium much more. So it may not be limestone in the underground, but bicarbonate, and this comes from the atmosphere, and from the soil especially. That means we have the rainwater is going through the atmosphere, and of course then it gets some CO2, and this means we have some bicarbonate already in our rainwater, and therefore the pH is less than neutral, a little bit, not much, due to only the CO2. Other concentrations in the air are not regarded here. For instance, NO2 or NO3, something like this, or sulfate or sulfuric acid are not regarded here. Only from the CO2. And in the soil, we have bacteria working and destroying their plant material. That means they produce a lot of CO2. That means in the soil we have a much higher CO2 content in the soil air than in the atmosphere. And this means we produce a lot of bicarbonate, and then it comes into the soil, or we produce this, get this in the soil, and then in the soil different cations are solved, additionally to the bicarbonate on the anion side. And this is not as clearly as, for instance, in the limestones, the calcium so much, but these are, as you see here, sodium or magnesia, calcium also a little bit, whatever comes. And therefore, this is really a meteoric water. No salt water, no something. No gypsum, no limestone water. This is just meteoric water. Yeah. So this is the interpretation behind it. This is very important for us as geoscientists. Yeah. Next principal component is then chloride and calcium magnesia, a little bit sulfate. This is also very interesting, and this leads also to the geology of Halle. Of course, you don't know it, neither the Berlin students nor in India. We have here a big fault, and on this fault we have an upconing of salt water and gypsum water. And this means by now we have the meteoric water mixing with this water coming up on this fault. And we have this typical ion exchange here. This water we can see here. Yeah. So this means we have on the one hand chloride. This is remaining in the water. Of course, it is not precipitating. And on the other hand, it is not solved together with sodium so much, but with the calcium and magnesia. Yeah, so it's an ion exchange water that we have here in our second component. Yeah, I'm a little bit astonished about the third component. Normally, I would expect here to have a clearly chloride, sodium chloride water. I don't know why this. Why we don't see it here, but this is only one observation well where we have this high loading here. No, we don't see a pure sodium chloride water or sodium chloride waters, and also not the gypsum waters, although no. We have a little bit of the gypsum waters here. Yeah, this water is derived from somewhere in or from the Upper Permian, and we have the typical precipitation order of, first of all, limestone. So this is at the bottom of these layers. Then follows gypsum, then the salt, and then potassium salts. Yeah, the sodium salts first, and then the potassium salts. This is mined already somewhere else, not in Halle. In Halle, we had a mining on the salt water. Because salt was very important, just as in India with the big way of Mahatma Gandhi. It was also just a little bit around it. Sorry for this, but I came to GNU in New Delhi and brought a little bit of salt from Halle, because Halle has its name. The town of Halle has its name from Halit, that means, or from the halite. That means in former times, over centuries, and really over centuries, but it's going back 3,000 years ago. We had the gaining of salt via evaporating of water. Yeah, and therefore, or this was very well known from Halle, and I brought a little bit of salt to JNU, and some of the colleagues said, how can you bring salt to India? This is, no, this, we don't want this. Due to Mahatma Gandhi, his salt marsh in the, when was it, in the 1940s, 50s? I don't know it exactly. So I didn't know about the history in India, and they didn't know about the history in Halle. So I only could say, oh, sorry for this, and take my salt. And other colleagues, of course, said were thankful and knew about this, and they have taken this with a smile. Others have taken this with a smile, and so it was very interesting. 1930 already. Oh, yeah, okay. 1930. Okay. Thank you very much. Okay, so a little bit about this, a little bit about history in the background, but it should not disturb us too much. So we see our components here. We see how we can connect also. So perhaps you can also carry out, based on these results, also the clustering, and you have here, for instance, the k-means cluster or the classical clustering. I might mostly take k-means clustering, and then you see you will get directly a relates table. So you see you have here the number of, or the identification of your observation well, and you have the XY coordinates also here in your table for these observation wells. And by now we can connect the cluster number, and we have only a few observation wells in cluster 2, and only one, I think, in cluster number 1. Yeah, this is this one. So you directly connect the results of multivariate statistics to the GIS, to these observation wells, to visualize here the cluster number. Yeah, and you see, in this part we have this cluster, in this part we have our cluster 1 with this only one point where we have perhaps the salt, and somewhere else we have the gypsum, we have the meteoric water, and therefore it is quite, or the ion exchange water, or whatever you want. So this is already very helpful to visualize then the spatial distribution. Yeah. So we can copy this here and save this in an extra file. Okay, so I can by now, or I can substitute by now the item by, how is this called in our original Excel file, or in the QGIS file, in the attribute table? Item. Okay, I can connect the item. Okay, I will not substitute it. So I save it as a CSV file. We learned that this is easy to handle and easy to connect. To relate to your CSV, and it should be cluster number. Okay, CSV format. Okay. Oops. And by now I close here the attribute table, and I go to the properties, and I use the joins and plus, and I didn't I didn't import my relates table here. By now I have the cluster number, CSV, no geometry, everything is okay. Okay, close, and now I can connect here our join cluster number, join field, item, and target field is also item, and everything is okay. By now I have in my okay, I hopefully have at in my attribute table, don't select anything here, which I have by now cluster number cluster. Yeah. There are two with cluster number 1. That's fine. And a lot of cluster number 2. And so on. And now I can visualize this. Yeah. I can use this to visualize the clusters here. And I say, okay, properties. I go to the symbology. And I say I want to have categorize the cluster number here. That we have seen by now, classify and apply and OK. And I see, okay, my cluster number 1 is here. The other one I don't see. Enlarge this a little bit. No, I don't see the other cluster number 1. Most of it is cluster number 3, which is the meteoric water, and there are also some of cluster number 2 here. Yeah. So they are distributed mainly here, but also some going over here, connected also with there, and yeah, I can interpret this by now. Yeah. So this is quite interesting. This connection between spatial distribution in GIS and multivariate statistics. So this is the first step here. Question. Okay. One way. Okay. How to export the cluster file from pass4. Yeah, it's very, very easy. To QGIS, of course. I just closed the the table. I go to clustering and take k-means and say I want to have 3 clusters. So this is my cluster. Oh, by now 1 is the meteoric water, and 2 is something else, and 3 is only only these 2. So it changes sometimes cluster number. It doesn't matter. So down here you have the button copy. And this copies the whole table into the memory, and then I open just one of these spreadsheets, and in this case it's Calc, it's not Excel, and I say right mouse click, einfügen, paste. Yeah, okay, Unicode is okay. And then you have it, and you can save it as a CSV file. CSV. You should save it as a CSV file. It's much easier than to. There is also a possibility somewhere in the extensions to import also Excel files, but it's a little bit tricky, and I don't want to have that many extensions loaded normally. Because this takes more time to load here. Yeah, and I say, okay, I want to save it somewhere, and I think the rest is quite straightforward, and I think you know it. Yeah, is this okay for you? Manori? First step is, of course, to create here this k-means clustering, and then to copy and so on. Yeah. Connection between the first connection between multivariate statistics and GIS. Yeah. You can do something like this cluster analysis, not only on hydrochemical parameters, but also on hydraulic parameters. Or I did it in my PhD thesis for instance, periodicities or periods that are observed in the groundwater, and shifts of periods, and of course also the amplitudes and so on of groundwater levels. Yeah, so you have a lot of parameters also in other settings that you can use aside of just hydrochemical analysis. Yeah. Okay. So, of course, we can by now also interpolate certain parameters. For instance, the bicarbonate is quite interesting. So by now you know also how to interpolate. For instance, with an IDW, here the interpolation attribute should be perhaps bicarbonate or whatever you want. Yeah, and you know, okay, 100 liters. Let's make it fast. And I say one, oops, wrong, okay, I didn't set the extent here, it should be from here, run and close, and I get the distribution here of bicarbonates. You see, there are only two with high concentrations in bicarbonate, yeah? All the others have quite low bicarbonate contents here, yeah? So, this is from yesterday, yeah? Of course, the non-geostatistical and geostatistical interpolation here. Okay. But it is a little bit difficult. We have a lot of parameters if we want to calculate with the distribution. It is also, you see, the main components, it's one thing, but if you have something like trace metals or organic parameters that you want to regard to, then you have completely different concentration ranges. With the main components, you are always in the frame of several milligrams per liter up to several hundred milligrams per liter. With some organics, you are in the range. If you take a dioxine as and at the other end, then you are in the frame of nanograms per liter. So this is not really helpful. If you want to compare this, if you want to calculate, for instance, is there any contamination at all? Yeah? Doesn't matter for me at the moment if this is from main components, because I have too much of, let's say, what do we have there? Perhaps too much nitrate or something. So this is also main component in the range of several milligrams or tens of milligrams. And on the other hand, I have, for instance, some pesticides with in the range of some micrograms per liter. So it is 1,000. If I add this, then this will not not give any reasonable result. Yeah. The question is, what can we do in terms of having different contaminations with different ranges of limits where I have to remediate the site or whatever. And therefore, I have to find a way to do this better. And I would suggest that we should have a 15 minutes break. And after this break, we will continue with this question, yeah? 15 minutes break. Please also think of the results here. If you have any questions, we have time for this also after this break, yeah? Okay. So back again. So we saw by now the first steps in the question, into the question of combining multivariate statistics with geostatistics. Of course, you cannot interpolate cluster numbers. This is ridiculous. But at least you see where these where the observation wells of which cluster are located. Yeah. So you get the spatial dimension then, but of course, cluster interpolation doesn't make sense. But we ended up with the question: how can we? Oh, I just saw that I've written the minutes completely wrong. Okay, but we ended up with the question: how can we combine our expertise in or our knowledge in terms of distributions of certain parameters, but with multi-parameters, with a lot of parameters. And there we have an interesting possibility. Yeah, if you think of having, I will open the screen again. If you think of having a lot of tables here, having this table with a lot of parameters, then each of these parameters has its own limits. Yeah? Yeah, it would be nice if we can, or the idea that is known as indicator kriging, or yeah, indicator kriging in the end. Behind this is that we take the limits to create a certain map. As so-called indicators, the limits. If you go to the resources management, for instance, mineral resources, then of course this may be your cutoff, yeah, instead of the limit. Of course, this is just the other way around. If you override the cutoff, or if you have more content than the cutoff, this is good. Here, it is good if you have less than the limit. In the environmental settings and in the question of contaminated sites and so on, and hydrogeology in general, seawater intrusion and whatever. Yeah, the idea that is coming up by now is, okay, we should have a reference to certain limits, and we can by now classify our whole data sets according to these limits. If I have a value higher than the limit, then I say, okay, this gets a 1. Yeah, this location gets a 1. And when I'm below the limits, or if the analysis results are below the limits, then it gets a 0. And then I interpolate for these, yeah, these are not concentrations. What is this? This is quite an interesting question. What is this kind of map where I interpolate only ones and zeros? Now this is the end then, or the idea behind this, what is the outcome. I have locations with ones and locations with zero, and I interpolate by now. But of course, these ones and zeros are not concentrations. Also, at a location where I below the limit, of course, I have some concentration there. This is clear, and this is not zero. I have prepared something for you, and I have prepared two Excel files. I close this here. I have prepared two Excel files in the folder Fictives. There is, if you unzip the lab pesticides, you will find nitrate and you will find terbutyl. Terbutyl is a pesticide, and whereas in nitrate you have the nitrate concentration here, and in terbutyl you have the terbutyl concentration. You have completely different concentrations. You see, this is micrograms per liter, and of course nitrate is measured, I should put it here, it is of course measured in milligrams per liter. So completely different ranges. Let's work with the limits. The limit for pesticides here in Germany is for each for single pesticides 0.1 microgram per liter. If you have the sum of all pesticides, the limit is 1 microgram per liter. So 0.1 for single pesticides, as it is here with terbutylazine. Terbutylazine is a pesticide for corn. It is used for corn fields. Okay, so for terbutylazine, the question of the limits is already solved here. Everywhere, or I did it already. So everywhere where I have a value below my 0.1 micrograms per liter, I insert a 0. Or and on the points and the locations where I have more than 0.1 microgram per liter, I have a 1. This is already here in the Excel file. I did this already for you. So by now, this question of the indicator is quite easy to understand, and it is quite straightforward. Here for terbutylazine. The other question is that of nitrate. The limit of nitrate in groundwater, at least in the European community, is what? Limit of nitrate.
Well, worldwide, I think it's 50, but I think we have 15.
It is, of course, 50. 50 milligrams per liter. 50 milligrams per liter. The discussion is, of course, the problem that we cannot hold this limit and cannot come back to this limit in wide parts of Germany. So therefore, we want to raise the limits. instead of solving the problem of having too much nitrate in it. And therefore, the argumentation is by now, do we need really 50 milligrams? Is it not suitable to have 90 milligrams per liter? Yeah, it doesn't matter so much. The health problems are not so big. So perhaps even 90 milligrams per liter are okay. Completely wrong discussion in my opinion, but this is the discussion, the political discussion at the moment. There is not a discussion if the agriculture should reduce their nitrate input, or this is also discussion, but there are a lot of demos and demonstrations and some other things going on. Due to this limit. Okay, so 50 milligrams per liter, and the question is how to insert this here as another value here for the nitrate. How can we do this? So we insert here limits or over limit. How can we can go through it. So this is below the limit, so this gets 0, 0, 0. Of course, this is all 0. But we have how many? 1,000 points, 1,100 points. We have a lot to do to get this. Idea? Yeah, we could write a formula, but it's even easier. We just sort it by column number 3, and for all of these, for all of those, so I do it like this. I sort it. Sortieren nach NO3. For nitrate, sort for nitrate, absteigend. So the highest values should be on top, top down. Okay, so there we have 1, and I copy the 1 to all these locations which are where we have more than 50 milligrams per liter. So all the others get 0. Yeah, that's very easy. Okay. So this is the short way. And it's even, but of course you can write formulas. It is not a question. If you write here, for instance, equals then Klammer auf. So this is of course in German. I'm sorry for this. This bigger 50. 1 times otherwise 0, yeah, and I can also use this formula top down, and it will give hopefully the same results, yeah. Okay, yeah, so there are of course a lot of ways to come to this result, even much more than these two. Okay, thank you. So we should work with this Excel file by now, and we know that we can use this only in QGIS when we save this as a .csv file. So I export this as a CSV. I first of all save it, of course, but I then will export this as a CSV file. So quite straightforward. Oh no, this was, I think, the wrong CSV, this one. And let's say save it. This is limits. And I know which one it is. Okay. Yes, I want to use this format. So this is the technical part here, how to come to this. I will also export this here, although with already the things inserted, or this classification inserted here, and I will save this as a CSV file so that I can import this afterwards very easily. Table tool is table tool limits, I call it here. So no, so that afterwards I know the two limit files are the ones that I have to use. Okay. Okay. So I now can load both of them. So this is first of all the nitrate limits, and I say okay, they have point coordinates, x and y are already known, well known, and I say and this is also okay here. I say add and close, and of course this is in another area. I will zoom to layer, and you see this is somewhere far away, but a lot of points, you know. So I can by now kill here my OSM layer and remove it. The hydrochemistry I can also remove here, interpolate it also the layer. Okay, we see by now this is in the Gauss-Krüger. No, this is not Gauss-Krüger. No, this is somewhere in the world. I don't know. Okay, but we can of course interpolate by now. This is very easy. Yeah, we perhaps use or we can use also, we can use also the Saga GIS to get a geostatistical interpolation. Yeah. So with the TIN interpolation, it's quite straightforward, as we know it. Nitrate limit, and it should be, in this case, the over limit, of course. And this is due to the fact that this will lead to 50 meters like this. No. Eh? Equal size. One leads to only one row, but there's something completely wrong. But the coordinates are correct. Or are they? Aren't they? Let's have a look. These are 30, yeah. Where are the problems for the interpolator? Should not be problematic. And extent should be from nitrate limit. Okay, it was the question of the extent. So 50 meters is quite okay for the raster size. So I get reasonable result from this. I have a lot of input, and therefore triangulation is suitable. IDW is better, and in this case, I assume, because then I have not the no data values up here and something here, somewhere here. But of course, geostatistical interpolation would be even much better. You know? And then I get, you see here, it is between 1 and 0. This is clear. This was what I wanted to interpolate, and I by now get the second, the Tabotulacin, table, and I say open, and I want to have it also with X and Y coordinates. Yeah. Everything is okay. Yeah, I say add and close, and I see this is only this part here. So not all of the fields have been investigated for pesticide input, but on the other hand, we have at least a certain area where we have an overlay between nitrate and pesticides, and we can interpolate by now also the pesticides here, the Tabotulacin. So also there, I take the tin in this case, and I will look for the indicators. Yeah, okay. So calculate from layer tab 2 limits, and there I say also I want to have 50 meters. Of course, it is smaller, therefore the interpolation is running faster, and only a few cells have to be interpolated, 80 by 111, 82 by 111. I run and close, and I have it. Oh, this looks completely different. So we have apples and pears. We have a distribution of pesticides, corn pesticides, and on the other hand, we have a distribution of nitrate. Of course, we think on the cornfields we should have pesticides as well as nitrate, but if I uncheck here the pesticides, and I see now not all of the area has values around 1 for the nitrate. Yeah? But for the pesticides, there are bigger areas with and a lot of locations with. But what does this mean, this map? These are not the concentrations. Just think about this, and we should have. You should have some time to think about this. These are only ones and zeros. Of course, in between you have other values than 1 and 0. Now this is clear. You have 0.5, you have 0.3 something. But what is this? I'll come back in a few seconds.
Wait, what was the question? Does anybody know?
Yeah, he said these are not the concentrations, and we should think about what went wrong.
So here I am. What are the ideas? What do these maps show? these two distributions.
Maybe it's an issue because we only have a digital, either a 1 or a 0. And here they try to smooth out the edges. I guess usually it makes the map look nicer, so you don't have large jumps in values. But for us, we only have 1s and 0s, so we need to be precise.
No. As I said, if you interpolate between these 1s and 0s, you have also 0.5 and 0 point something. It will not be more than 1. This is clear. And it will be not less than 0, but in between you have a lot of values. Now, if I go around here and ask for the interpolation results, then I see this down here in the corner. You see here 0.26, 0.000, 0.55, something like this you have in between. Yeah.
But how can that be? I'm sorry, I don't understand. We only have 1s and 0s, so it should either be white or black. And in between, why would that happen? I think aren't we just putting it with coordinates on the same map? So we're not really multiplying it or anything with any other parameter. We're just putting it with coordinates. So
yeah. But this is nice in interpolation. If you take, for instance, nearest neighbor, then you have only 1s and 0s. This is clear. But if you take an interpolation like the tin, then of course, if you have a 1 here and a 0 here, in between you have an interpolation. You have all the other values.
Well, but this is not useful technique for us then, for this at least, or?
Is it, or is it not? What is this map showing? It is not showing any concentrations. This is clear. It is also not showing where we are beyond our limits. What does this map show? This is a strange map. So we can throw it away and say, nice that we can do this technically. Any idea? Any other idea? Why does Gosselt make it for nitrate and for pesticides? Of course, in both cases we get a 0 to 1 map. You know? This is nice. Whereas the limit in terbutylazine, for terbutylazine is 0.1 microgram per liter, and for the nitrate we have 50 milligrams per liter. So these are thousands of, so this is factor 50,000, no, 500,000. Is it right? Yeah, 500,000 of the limits. We have by now maps of only, which range only between 0 and 1.
Oh, but it's the danger of agriculture or agricultural impact on our groundwater. And these are these areas.
You are on the right track. You are really on the right track. It is the probability map that we override the limit. It may be here in agriculture, it may be for a contaminated site, for some other completely different parameters or whatever. What we have by now is a map, or what we get here is a map showing the probability that we override the limit. And the limit may be in the one case here 0.1 microgram per liter, and in the other case 50 milligrams per liter. We have a probability map by now. And this means by now I can get the probability, or I can get a new probability map where I show that the probability that I override either the limits of pesticides or the limit of nitrate. Of course, here for the agricultural land, I doubt that it makes sense, but in terms of contaminated sites, this is quite interesting. Because, for instance, if you take the limits for PAH something, I don't know the limits there, they are very complicated. And on the other hand, for chlorinated hydrocarbons, then of course these limits are on different levels. But for a remediation of this site, to dig it out, to remediate it, and to put it afterwards inside or back to the location, it is quite interesting. On the one hand, it doesn't matter if I take out, it is interesting if I have a contamination at all, and where we have probably no contamination. And on the other hand, the remediation technique may remediate the PAH as well as the chlorinated hydrocarbons. Therefore, I find the areas or the part of the area where I have to dig out, remediate it, and put it in afterwards. Yeah, and for me, it doesn't matter if these are chlorinated hydrocarbons that I remediate with this technique, or if I remediate the PAH, or trace metals, or whatever, yeah? So, quite interesting result here, but very unusual. It is completely different from all the maps that we know so far. But we by now can compare apples with pears, yeah? Here it is best, terbutylacin, pesticide, very, very low limits. These are my apples, nitrate with high limits and completely different distribution. These are my peers, and I can now make a composition of both. So, I hope this tastes well, apples with pears. I think so. And on the other hand, also this kind of maps makes sense. And this, in my opinion, is quite very interesting here. Yeah. So it helps us, especially in environmental geology, in the question of hydrogeology, if I have mixtures of water and so on. Of course, this is no process modeling. Yeah? If I just told you about mixture of water, then of course this mixture of water will get to some if you mix waters, then you will get different or a lot of hydrochemical reactions. But on the other hand, and this cannot be modeled in this way, yeah, because this is no process modeling. Yeah, but this is just a statistical modeling. But on the other hand, in some circumstances, this helps a lot. Yeah. Questions about this? Okay, then I think we should calculate the probability that one of both is overriding the limits. Yeah, it's going beyond the limits. And this is done with the so-called raster calculator. Yeah, I take here raster and raster calculator. And I should have a step before this. I have to export this as a raster file to see afterwards what is what. So this is my interpolated raster for the terbutylacin, of course. it as, and it should be saved as geotiff. I will do this, I have to do this slowly. Sorry for this. So once again, we have our interpolated results here. Of course, this is only tin. Yeah, I did it for so that it is fast. Of course, if you are working on a project, you should do it with geostatistics. This is clear. But also there, the result is a raster. Okay, so I export this, save this as a geotiff. In this case, this is Tabutur. Tabutur tin. Of course, we have to be careful because there are also some organic tin substances, chemical substances, and this is not the tin, it is only the triangular irregular network. Speichern. Yeah, okay, this doesn't matter. Okay. So this is my, and by now delete here the distribution that is not saved, the temporary result here, interpolation result, and this I will also export by now. Also as a geotiff, but it is not tabutyl tin, but it is in this case nitrate tin. I say okay. And let's throw away my interpolated, my temporary result. Okay, so by now I have two saved distributions, completely different area, completely, yeah, okay. So based on this, we can by now interpolate, we can by now calculate the risk that we override the limit of nitrate or tabutyl in this area. But we can do this also for a whole of the area. Yeah. Of course, here in the areas you will not have, you will not be beyond the limits of tabutyl. This is clear. Only nitrate. So, as I said, this is done with the raster calculator. Yeah. We go to raster and raster calculator. And there we have by now, in my case, nitrate and tabutyl. And this raster calculator is a marvelous tool. It is really a very mighty tool. So if we want to find out, or if we want to calculate here, we first have to find out or we know in the background that we have the probability maps here. So we say if we have a probability of more than 50%, either of nitrate or of tabutyl, or the first thing is we can calculate the sum of both. Yeah. So this is very easy. Just to show you, we create a new raster layer, and this is completely different from handling in vector data sets. In vector data sets, you just add a new attribute, and then you calculate in the attribute table. with the field calculator. Here you have, because in your raster, you saw this yesterday, you have saved for each of these raster cells only one value. And there is no possibility in the data format to save 2 or 3 or something values. Therefore, you have to create a new raster to work with the other rasters. You can have here 5, 10 rasters, doesn't matter. Now, so we have to create a new raster, and I call this sum. Yeah, correct folder. So this is the sum of limits. And I say, I want to save it as a GeoTIFF, everything okay. And I just have to add nitrate plus tableau. Yeah? Very easy. But then, of course, if I have a probability of 50% for the tableau and 50% of nitrate, then I get a 1. Yeah. Perhaps this is what I want, but perhaps I want to divide this by 2. Yeah? I want to have a probability between 0 and 1, and this is quite easy. I just insert here the brackets and divide this by 2. Oops, no, this is not the best idea. Always use, please always use these buttons here. So then I get also a range between 0 and 1. Yeah. I say okay, and yeah, by now it is at the bottom here. The result is this one. Yeah. Of course, where I have null values in the tableau raster, there I have only the value only the value of the it is, let me have a look. Okay, it is calculating only for the area where I have both. Yeah. Okay, this is correct. Okay, fine. So by now I know, okay, here in these areas there is the highest probability that I have both. Yeah? Or that I have at least one on a very high, no, that I have both. Yeah, that I get both. But in these areas, there we have only, let me have a look, there we have only a 0.3, 0.4, something like this, a probability, and this means there certainly I have only one of them, but I don't know if this is nitrate or if this is tableau. Yeah. I don't know it. Just from a probability distribution of both, I don't know it. But here I know, of course, these 0.8 I can reach only with when I divide it by 2. If I have a high probability to override the limits for both parameters. No? Okay. But with the raster calculator, you can do a lot more. Yeah. Just let me show this to you at this example here. I have by now 3 rasters. Of course, this is the new one here. For instance, you can find out all the areas where you have, for instance, more than where you have a probability higher than 50% of the nitrate or of the tableau. And this is done within clauses, and within these clauses you you set a relation. Yeah, that means I want to find out all the areas where nitrate is where the probability of nitrate is more than 50%. Yeah. So I open the brackets here, the clauses, the brackets here, and I say nitrate higher than 0.5, and I close it here, and then within the brackets I have only the information, either at this raster point it is overriding, it is higher than 0.5, or no, so 1 and 0. So my extraction with the ones and zeros I could have done also based on the interpolation result, perhaps for the nitrate, based on these rasters. Yeah? And then I can multiply this 0 or 1 with some value. Yeah? But I will get only either this value or 0. Yeah? Because this is either 1 or it is 0. Yeah? And I can also add something, but I must be aware that I have here either a 1 or a 0. If I add something, for instance 5, then I can get a 6 or I can get a 5. So multiply this here. Of course, this will be only either this here or 0. In this way, I can select values. Yeah. So why is this not valid? Because I didn't set here the raster name. I just leave it like this because this is just for demonstrating some demonstrating that it works and how it works. Okay, so yeah, this is the area where I have a probability of higher than 50% that nitrate is beyond the limits. So this is quite interesting. Yeah, of course you can also do it in another way. Yeah? You can also say, okay, I do the same selection again, nitrates higher than 0.5, and now I multiply this not with a single value, but I multiply this by now with the turbo 2. Of course, this also doesn't make sense at the moment, but for some questions this makes sense. Yeah? Of course, I get then only the value of either the turbo 2 or 0. This is clear, because the one, if I have here values of nitrate beyond the 0.5, probabilities beyond 0.5, then I get a 1 here. And then this is multiplied, this 1 is multiplied by the value for turbo 2. Otherwise I get a 0, and then this is 0 multiplied by something, 0. So this is very tricky, and this is a very, very mighty tool to calculate with rasters, to handle rasters. So I just click out the other map. So this I click out, yeah. So here I have more than 50% of nitrate, and I multiplied this with turbo 2. With the percent, or with the probability for turbo 2. So quite interesting and tricky. Yeah, very tricky. Okay, any questions about this? So in a programming language, these brackets are something like an if. Yeah. If we have more than 50%, then multiply this with this 1 that we get, then set it to 1 and multiply this perhaps with this turbo 2 Latin or whatever you want. Yeah. And believe me, I have seen such selections and multiplications and so on, which fill one A4 page. Yeah, very long selections and something. This maybe in terms of, for instance, flooding events. If I have a water level higher than this, then only then this house or the cellar of this house is flooded. This is no linear correlation. If the water level doesn't reach this this point of this window where the cellar is flooded, it will not flood the cellar. Yeah, and so this is quite interesting in terms of hydrology, hydrogeology, hydrochemistry. We do it by now for the hydrochemistry, but the method itself is very universal and more general than only this application here. Yeah. Okay. Let me have a look. Yeah, it's too early, or we don't have the time to start by now with the next topic. We will not finish this before lunchtime. Either we can have later lunchtime, or we make by now lunch. Yeah, this will be helpful. I think we should have a 60 minutes lunch break by now. It's a little bit earlier than yesterday or in the last days, but we should start after lunchtime with a new topic. On the one hand, with a short introduction, but this is very short. But on the other hand, with a long lab afterwards, and we will look for cross sections at the beginning. So this is a very general topic, especially for geologists. This is very helpful. And then later in the afternoon, we will have also a very short look on an introduction to Python programming in GIS, in QGIS. Yeah, this is a very interesting topic, which helps you, or which may help you really a lot from my point of view. What my experience is with the students here, this is a completely new field. But on the other hand, it is a nice field where you have a lot of power to do things that you want to do. Okay, that we need, especially also as hydrogeologists. Okay, so lunch break, 60 minutes. Quarter to 12, quarter to 1, Germans are back, and oh, no, this is too difficult right now at the moment for India. Yeah, okay, see you. So back again. Yeah, for today, for the afternoon, we have two big topics. One quite big topic, and the other one is very, very big, but we will only go into detail, or we will not go into detail there. The first one is about cross-section maps, and this leads to the question, how can we handle 3D information in a GIS in general? It's not connected to QGIS, but it's the same in ArcGIS, or whatever GIS you want to use, GrassGIS, whatever. Normally, or in the past, geographic information systems were made for geographers. This means for the surface of the Earth. But it became a geo-information system over the time, and therefore the question arises how to handle data below the ground surface. And of course, you are geologists mainly, or in most cases, and therefore the question, and therefore you are used to cross-sections. In nearly each geological map, we find a cross-section, either in the explanations around the map or within a small booklet or whatever, so that we get an idea about the underground beyond the bare map at the for the surface. But normally you only have one or two or maximum three cross-sections for such a geological map, and not more. But in hydrogeology, also cross-sections play an important role, and therefore we have different kinds of maps, and we will have a look at these by now. So hydrogeological cross-sections should show, on one hand, of course, the groundwater level, and the kind of the aquifer and the lithology. This is very important because, especially from the lithology, you can derive already a little bit of the hydrochemistry. We find here for the kind of aquifer, or from this information we can derive, according to the standard legend, if this aquifer has a high hydraulic conductivity, high yield or whatever, and therefore it's good to have at least this information. Perhaps there is also the possibility to insert even more information to get it here into the cross-section. So I mentioned already the first steps for 3D hydrogeology, but of course we have also only a screen. We have only some other some paper or something. So this is also 2D. The question is then in geology we have highly developed tools to model in 3D. Do you use any tools, or do you know about any tools to digitally represent geological topics? Okay. ArcGIS. Okay. Telia, I don't know. Interesting. So with ArcGIS, it's a little bit tricky, and it's the same as we will do it today. It's from Panama. Interesting. Okay. Okay. That's nice. Okay. Yeah, I mentioned already when we come back to the pollen here, or to visualize pollen data. Okay. So be aware that of course we can handle somehow the photogrammetry data, yeah, and this is 3D, real 3D. We have done it here in our working group. For instance, a cave in the underground to find out where are weak parts of overburden, where maybe the possibility that this cave breaks together and that houses are, or even people are, that houses get damaged and people are injured by this, and this is one possibility, but it is not common. This is very difficult and very tricky. Some very famous tools for geological modeling are, for instance, GoCAD. Today it is called a little bit different. This is Petrel. These are the biggest tools. Of course, they are from the oil industry and the mineral resources industry. This is clear. But there is also something like Move 3D. And there is also a tool called Andino from somewhere in South America. So these are just a few names. If you are interested in this topic, please have a look at this. Of course, there are a bunch more of tools. So let's say around about 10, 15 tools are available that we have tested also in some circumstances. What are the pros and cons of each of the tools? So there is Leapfrog, for instance. There is what else? Rockworks. So there are some more tools than these four, but Move 3D and Andino have the advantage that, especially for our students, they have the advantage that the introduction to these tools is not so or is good to do within let's say 2-3 months. Yeah, normally you need for GoCAD and Petrel you need years of work with these tools to get used to them, and therefore you need a very high specialization in this 3D modeling there. Okay, but we will do it with ArcGIS, not with ArcGIS, but with QGIS and SagaGIS, as you will see. And on the other hand, GIS is normally not suitable for 3D, only for 2D. And we can use it, on the other hand, to set up cross-sections. And this is also 2D, of course. And the question of, or these buttons like in SagaGIS where you have 3D, of course this is a surface in 3D space, but the coordinates that are used are nevertheless 2D. We have not XYZ plus a value. Okay. So one possibility we saw already, or we got an idea of, is to create cross sections in GeoDin with the basic geological data that we get from the field or that we collect in the field. You can save these cross sections as graphics. This is possible even with the demo version or with the GeoD Shuttle version. It is not a demo version, it is GeoD Shuttle. It's much more than a demo version, as I said, as I explained. And then these graphics can be georeferenced and inserted into a map. Or you can handle this at least like a scanned map. That means, of course, along your cross-section line, you can give it the 2D coordinates, or you can you have the distance to the beginning of your cross-section as one one axis of your diagram or of your cross-section in the end, and on the other hand, in the y direction, you have, of course, the depth, or the other way around. Depth around the scaling, the metric scaling for the depth or the level above meters above sea level. So you can georeference this. You have both, of course, when you create such a cross-section, and therefore you can georeference this, of course, not in the normal way. It's a little bit strange to look at meters above sea level as the second coordinate, but on the other hand, it is possible. From these cross-sections, you can then come to a 3D geological model by meshing a lot of these cross-sections and connecting everything, and then or putting all the information, first of all, in your cross-section, and then get this information back from your cross-section view back to the map view, let's say it like this, where you have the possibility of just normal interpolation, for instance, of hydrogeological structures or something. And if you do this, then you have at least the flying carpets, as I say, as I call them, these surfaces or the bottom faces of the for your 3D model with some. It is in the end no volumetric model then. It is just a model of these surfaces or bottom faces. The problem with this is if you work, for instance, with rasters, then of course the raster has to be everywhere in your area. You can set somewhere null values, this is not a problem, but there is no real fading out. There is a problem with some of the faults, especially if you have faults with where you have two layers, or where you have the layer two times in the depth, so this cannot be handled somehow in a raster. So it is a little bit tricky, and even from the data format side, it will not be easy to handle. This, of course, can be done with geological modeling tools. Of course, we want to create hydrogeological models, not geological models. So the parameters are not the stratigraphy or the lithology anymore, but the parameter is, of course, our hydraulic conductivity, or transmissivity. Maybe no, transmissivity is not suitable. Hydraulic conductivity is correct. You may use, for instance, the lithology here in these cross sections as a signature, but the main thing should be the hydraulic conductivity. You can play around with some things. You see, see here on the slide some recommendations from my side, from my experience in the past. How long do I do 3D geological and hydrogeological modeling? 25 years, something like this. Okay, an example here from, once again, from former GDR. This is a very strange map of cross-sections. So on the one hand, in the background, you have the normal map view. And there you, on this map, you find these cross-sections, these schematic cross-sections. And they have nothing to do with any thickness or whatever. It is just outlining the stratigraphical or the units. No, these are hydrogeological units. If they are there or not. So, for instance, along this cross section here, you have here in this part not the uppermost aquifer. Here you have it, and here you have it also not. So in this part you have, for instance, your Weichselian, this is the last ice age, and the Holocene aquifer, but here you don't have it. Then you have here in this part, for instance, a till, and here you don't have this till all over this part. Then in the next, this is hanging something, there is hanging something at the bottom, going down from the bottom of the uppermost layer, of the Holocene layer. And then you have this, this layer here, where only in this part you have an aquifer, and all the other, in all the other parts of my cross-section up here, of my cross-section line, you don't have it. Yeah? And so on and so on. And this is very tricky to read. This explanation from my side makes it perhaps a little bit easier, but on the other hand, you have to carefully look for the legend, because sometimes you have here, how many units are these? 5, 4, 6, 7. So you have 7 units here, but more to the north, it may be that you have 10 units, more to the south, you don't have something like, or certain, you don't have certain ice ages, therefore you have a reduced number of layers shown here, and so on. And especially it has nothing to do with any thicknesses or whatever. Very difficult to read. Me, I also need by now 5 to 10 minutes to see, okay, this is this till, and this is this sandy layer, and we have here these, not scaling, but we have these stratigraphical layers here represented in a hydrogeological map. So very difficult to read. And very uncommon, although I don't know if somewhere in the, on the Earth there is another map like this. Most complicated and yeah, very tricky to read. The more common are cross-sections like this. For instance, in North Rhine-Westphalia, the University of Aachen has got from the Geological Survey in North Rhine-Westphalia is a contract that they should do all hydrogeological maps at the Lower Rhine, at the Niederrhein. Lower Rhine area. And they decided, they got this contract already in the 1950s or 60s, somewhere there, and they decided, oh, we don't want to have the hydrogeology in the form of a classical map. We want to show 3D hydrogeology. This is most important because there we have a lot of very deep reaching lignite mining areas. And therefore also the look into the depths is very important, and therefore they decided, okay, we will do it like this. Yeah, and you have your cross sections here. You have all. You see also the thickness. You see the lithology and so on. So this is quite nice, but it is the only area where I know that these kinds of cross sections are created. Yeah. Okay, so this is already the background, the theoretical background. Any questions about it? There's any remarks, any ideas? Anything from your experience about cross-section, hydrogeological cross-sections? Okay. Then we should continue to create cross-sections in our GIS, in QGIS and SAGA-GIS. First of all, for a cross-section, you need, of course, a topographical map. That means especially the morphology. And yesterday we already got, oh no, I will close this completely down. This is faster and easier than to kill everything or to remove all the layers. So once again, open the screen here so that you can see what I'm doing. So yesterday we got the information for Eschwege area, and this is quite a good area to construct and to see how the construction of cross-section helps here in interpretation of hydrogeology. Yeah? So let's have a look. We got data, the point data for the topography yesterday in the afternoon, I think, for the geostatistical interpolation. We didn't finish this, therefore I do this again. So the point data are available in ESW again, and there we have the height point all from yesterday. Yeah, not height lines, sorry, height points all. Not height lines all, but height points all. You can also convert lines to points. This is possible with a small tool that we have in our toolbox. But you will find this. This is no question. So height points all. We need here by now. We say add. We say and you say okay. This should be Gauss-Krüger zone 3 once again. So we are in Eschwege, not in Berlin or in Halle with zone 4. Here it is zone 3, and say OK and add and close. And oh, I added it 2 times. Of course, this is only misleading. OK, so this was our point data set, and we should now. Perhaps it's a good idea to do this by now. Did we get this also as no. I save this as a raster file. Okay, no, I didn't. We should fastly. The problem will be I was somewhere. We have to open the attribute table. And there was somewhere the elevation of null. Only a few points, and we have to select them. We have to set them. I'm sorry for this. This I have forgotten overnight to correct this. So this is a long one line here. I just load also the height lines to see height points, height lines, all okay. So, no, we should just kill this. By now I know where it comes from. So we should just delete these points. It doesn't matter. It doesn't change our whole elevation model. So just setting this editable or for edit, and then we mark all these elevation null points. You can choose here elevation, then it will sort the elevation, and you just mark all the rows where we have this null value in. Yeah. Okay, and then I say I want to delete it, and it's deleted. And I save this. And now I'm ready for the interpolation with tin, for instance. Yeah, we take tin today. It should be okay. Tin interpolation, and we don't take the height lines, but we should take the height points, because we corrected by now the height points. And the interpolation attribute is of course the elevation, and we add this here. We say we want to have, first of all, the extent. Of course, we get it from the height points all layer, and we want to have it, no, not the number of rows, we want to have a, let's say, 25 meters raster, yeah? I take it a little bit smaller because afterwards or when we work afterwards with this, it is better to have a higher resolution raster, yeah? I say run, close, and I have a quite nice raster data set with the heights of Eschwege. Yeah. So by now, the other information that we need for a cross section is of course what? And now in Chorus, what is by now the or what is the other information that we need aside from the morphology? Nobody answers? Why not? You are all geologists. Of course. The geology. We know that we have our geology feature. So I open this here and I add this and close, and it's there. Yeah. So by now, based on this information, on these two information parts, we want to create our cross-section. We have also boreholes, and we will try to insert this information also afterwards into our cross-section. But by now, we will start here with the creating the cross-section. Only based on morphology and the geology. Of course, it's most interesting to have a section across this valley here, and we will start in the north and go here around and go strictly to the south here. Yeah, this should be quite helpful, and I will focus here on the geology map, zoom to this geology map so that I have the best extent here for the creation of my cross-section line. Because we first of all need a cross-section line. Yeah? Okay. To create a line, a layer, it is quite easy. So we go to layer, create layer. There's also the possibility somewhere here. Is this also for creating layers? New shapefile layer, yeah. You can also pick this button here, but you can also go where create layer, new shapefile layer. Okay. Come on. Oops. Somewhere here. Okay. So the file name. Yeah, it is, we are in the correct, yeah, cross-section line. Cross-section line. Shapefile layer, this is okay, but we want a line. So the geometry type should be line string, line, yeah. And we don't want to have it in WGS 84, we want to have it in, come on.
DHDN.
DHDN, yeah, thank you. It is DHDN, Gauss-Krüger Zone 3, yeah? Okay. Thank you. And the new field, no, we don't need a field. We only draw one line and it should get only the ID. This is enough. Yeah? Okay. So, ready to go. We say okay. We should set also the geology here has the layer CRS of Gauss-Krüger Zone 3. This is predefined, and we should set this here also as coordinate reference system for the layer, for the project. Sorry, yeah, so that we are sure. This editing we have to stop here. Hide points all editing. I don't know if this was editable here in your case. In my case, it was editable. Of course, I have to stop editing by now because I want to edit by now the cross-section line. Yeah. So I activate it and I take here the cross-section, the editing. And here I see, okay, I can draw new lines. And we just pick it like this, and I start here, and I go around here. It needn't be straight. You know, you can set angles. I will do some extra part here. So, this is my cross-section line by now. It gets ID 1. I do it a little bit thicker. I will present it a little bit thicker, but I stop editing by now. Save it, yeah, and I make it a little bit thicker. So, there. Okay. My cross-section line. You don't have to do it like this, but East-West is not so spectacular. There you have always, or nearly always, the same layers if you do it here. If you do it here, it's a little bit more interesting, but yeah. Okay, by now we have to export our interpolated surface so that we can use this also in SagaGIS. Yeah, this is a little bit tricky because you remember from yesterday, SagaGIS exports and imports a lot of raster data file formats. But QGIS doesn't or has another range of import and export formats, and therefore we have to look that we export this as a Saga grid file. Yeah. So export, save as, and of course not as GeoTIFF in this case, but we have to pick here. You see, there is also from Golden Software, this is Surfer, but in this case, these are binary grids. So SagaGIS will not read this. From ArcGIS, ArcInfo, whatever, the ASCII grids, they are not there. That's bad. On the other hand, if you go down here, then you see SagaGIS binary grid is supported, and therefore we should pick this one. No? Of course, we have to set the file name. So morphology or topography, whatever you may call it. And it's then saved as Saga grid. And I say OK. And by now, on the one hand, it is added here in QGIS. But here, no, I will not delete it here. I will remove this temporary layer, but we have the why is the morphology not there? We don't see it because no data value is black, and compared to the no data value, all the others are white. They are on another level. So very strange. Okay, I will delete this here also. But it was also strange. Let me have a look. This was quite strange. It was in another area. So morphology as that. But there should be the cross-section line on top and the geology on top. I have to set the layers here as, perhaps it's only this. No, it has no coordinates at all. What's that? Let's have a look if it's the same with SagaGIS. This is quite strange. Otherwise, we have to interpolate in SagaGIS once again. So I try to open here the morphology S grid. Okay. No, it has no coordinates at all. That's strange, and we should not continue at this point with the grid from QGIS. This is very, very strange. This didn't happen to me before. Okay. Let's go back to this layer. Okay, then we should also delete this here from GIS. And on the other hand, we can open by now, once again, sorry for this, the height points in GIS. And then we should interpolate, perhaps directly with Krinking. We take our ordinary Krinking. We have the height points with the elevation. Cell size should not be 15 but 20 meters. No, 25 meters we have chosen. Okay, and then everything is okay. Nodes okay. But we have to. Yesterday we learned that we have to have a bigger search radius of 1,000 meters at least, and only one point minimum. With the maximum, everything is okay, but it should be the maximum search distance should be set to 1,000 meters, because otherwise, in the center of the valley, we have areas where it's 400, 500, 600 meters away. The raster points are away from the next measurement point. I say okay, and I get the variogram by now, and you remember from yesterday, we take just the squared and we fix it to having no nugget effect, and then we have to adapt it a little bit like this. Okay. Now, so to get the nugget effect out, you have to just delete the A plus in front of the equation down here, or of the term that is used here. And on the other hand, to fit it best, you can use this slide bar. And I say OK. And now it calculates the distribution, 25 meters, and hopefully we have no gaps. No, this was the points. There are no gaps. Good. Okay. Fine. Okay. Now we should call the cross-section line, or we should import the cross-section line. Of course, this is a shapefile. This is very easy to import. So we have it here. We saved it before the cross-section line. I hope that this has the correct coordinates. And of course, once again, we don't see it. But this time, when we visualize this, we should use the elevation here. Yeah, we should set it on top of the elevation and say, okay, yeah, it has the correct coordinate system. Yeah, it's working quite well. Okay. So that's nice already. The background is that in GIS we have a tool for, where is it? For profiles, terrain analysis, profiles. Yeah? Terrain analysis, profiles. And there we have profiles from lines. This is a very nice tool. Yeah? You can do this also interactively, but yeah, this is a little bit tricky and so on, and therefore I prefer to prepare properly my cross-section line, lay it around my over my geological map so that I see also what is which units are there, and that I pick most of the units and get the most important or most the most important features here, the most important units, and on the other hand the best place for this cross-section line. So, and now I take profiles from lines, and now I have to define my grid system. Of course, this is my elevation here. I don't delete the things here at this point, it doesn't matter. The then, of course, is given also by these, by the elevation. Values, no more objects. This is okay. The lines, of course, there I pick the cross-section line. Name is the ID, it doesn't matter. The profiles, the profile has to be created, and therefore I pick here, instead of not set, I pick here create. Yeah. And now I say OK. And here, tool execution succeeded. We should have a short look at this. The result of this is not a line. This is only our cross-section line, but it is this point data set, and this is very interesting. Yeah? If we open this in a new map, no. Okay, no. It is this one. Yeah, it is this one, sorry, with the elevation. You see, we have created points in a distance of 25 meters just along this line that we digitized. Yeah? So, really nice. Perhaps we also can open the attribute table. So, attributes and show. Yeah. We can show this also as diagram, but in our case, it's better to see the attributes here. Show, and you see, interesting. Of course, we got our x, y, z. Yeah, so these are the normal coordinates, and z is the morphology here. It is what we wanted to get out here. But we get also the distance and the distance at the surface. So the distance at the surface should be a little bit bigger than, because if it goes up, then of course you have an angle, and it takes a longer path than in horizontal dimensions. It should be a little bit bigger than the distance in horizontal. Yeah? But it's very, very nice from SagaGIS that it exports also the distance from the starting point of my cross-section line here. Yeah? This is very nice. And we just can export this here. How can we export this? No. We have to export this somehow. I close this and I save this. It's no problem. The problem is that I marked by now one point, and if I export this by now, then it will only export this one point, I think. Okay, with this I can unselect it also. Yeah, this point here, I can unselect it here. Okay, now I will export this here. Then of course I get also the attribute table. This is no question, and I will save this as reshape file. So I will give it another name here. Hide points all, but only for the oops. Come on. But profile. Yeah. Hide points all profile. Save. And now when I go back to QGIS, I of course can visualize this shapefile in the map view. This is no question. Easy to do. I just opened this here. This was my no. Where did I save it? It was the wrong place where I saved it. I don't find it anymore. I have to save it again. Sorry. In Lab 2 in, completely wrong folder. Sorry. This was my mistake. Just doing it all again. So hide points all profile in ESW is okay. So by now it should be there. Come on. Hide points all profile. Shape. Okay, I open it, I add it, I close it. You see they are there. Yeah, in the map they are there. But if we open the attribute file with attribute table, then we see, okay, my distance is also there. And I need the distance from the beginning of the cross-section line. Yeah. So by now I can either somehow export this here. No. I will just copy everything here, mark the whole table, the whole attribute table, Control C for copying it, and then going to, let's say, Excel. Then I can visualize this also quite nicely. I insert, I paste it, I kill the first line, the first row, löschen, and then I will just sort this for the distance. I think this is a good idea. So sort this for distance, Daten, sortieren und nach Spalte C. Distance. By now I take this distance row, column and the Z column to get via F11 in this case a cross section. Oh, excellent. What's that? So you have a first cross section here. Yeah? In Excel. I think this is nice. I hope you find it too. You think it too. Yeah? So, okay. Nice, nice. But we want to work on this and we want to get the geology. Okay. We close Excel again, but we have an idea it works. We get something like this. So I unselect everything, but I'm staying here. I will close down Saga by now, so that I see your comments on this nice tool. Okay, you didn't give me any comments. I will Also delete this here. So I'm back here in QGIS. And I see I have my points, but I want to get the geology to these points, the geological information. I need this. And yeah, it's quite easy. Because we know that we can intersect. For instance, polygons with polygons. We did this on Tuesday. But in this case, we have points and polygons. And therefore, we cannot intersect. We have to find another method. And there is a nice method called points, no, not random points and polygons. Count point in polygons. I think this was it. Otherwise, it is the method join attributes by location. One of these two tools. I start here with count points in polygon. Polygons are our geology. Height points all for the profile. And no, from this, no. But it may be close, no. Let's have a look at our height points if they got some new attributes. No. Okay, so the other thing is remove this layer. The other possibility is more helpful. So vector, data management tools, and then join attributes by location. And the base layer is the height points or profile. The join layer is then the geology. Yeah? Yes, and here we can pick if it should intersect, if it should contain within. Yeah, I check all these three things. Then the chance is big that I will get what I want. So let's continue here. Create separate feature for each matching feature. Yeah. One to many. Okay. Joint prefix. No, this is not necessary. Joint layer. Optional. No, we try it like this. Yeah. We run it and close it. And we should have a look at the attribute table, and the stratigraphy is there. That's fine. So we got the geological information. We have, of course, the distance from before, and we have XY coordinates, and we have Z. Everything there. The only thing is that this will be very flat, because if we have no exaggeration, then it will be quite a flat profile, yeah, without exaggeration. The exaggeration is not 0, but the exaggeration is 1. That means, of course, if you have 500, if you have a height of 500 meters, it will be with 500 in the y dimension, but in x dimension, this is 500 meters are also 500 meters. So the exaggeration of 1, this will not be helpful. Therefore, I create also exaggeration of 5 and of 10. And this is a very simple trick. I just take my table here, I copy it as I did before to Excel, string V, no, Control V for pasting it. I delete here the first column. And by now I make a new field here, or I calculate here exaggeration 5 and a new column of exaggeration 10, and I just multiply this. This equals Z multiplied by 5, and this is Z equals Z multiplied by 10. And I do this for all of the points. Okay. Now I save this as a CSV file. Of course, we are sure that we can import this in a QGIS. So I save this as not in the fictive, but in ESW, and it should be CSV, and it should be cross-section CS points. A warning that the whole Earth will be destroyed if you save it in this format, which is not the Excel format. Strange. Okay. So by now I close down this, and I think, yeah, this is temporary. I will save also this this temporary layer with the joint geology here. We don't know when we want to come back to this point, and therefore it's a good idea to save it here. So it is called CS points geol. And shapefile, and OK, and OK, and OK. So everything. OK, now I can remove this layer, and I can close down QGIS, because by now I want to use QGIS for vertical data. Yeah, and it is not. Or you in this case, perhaps, no, we will come to this, back to this later on. Okay, so we close down here QGIS. And now we open it again. But by now we will not load a shapefile of our maps, or any map, but we will open our CSV file that we just created. So we go to the text file opening, and we open here the cspoints.csv, say open. Of course it should be with coordinates. Yeah? Hopefully you see it like this. But the X field in a cross-section is not X. This is in a map. In a cross-section, the X field is our distance. And the Y field is not Y, but it is Z. Yeah, this was why we did it all in Saga GIS. And I say add, and it doesn't matter if it's Gauss-Krüger zone 4 or 3 or whatever. This all doesn't matter. I say okay, and close, and now it's there. The problem is this is the cross section without exaggeration. Yeah, and you see this is very flat. You cannot work with this properly. Therefore, I would suggest to open this CSV file again and take, for instance, the exaggeration of 5 as the Y field. So the distance for the X field is okay, but for the Y field, it's not suitable to have Z, but exaggeration 5. Yeah, and I say add and close, and then I see, yeah, fine. This is how the area looks like normally. So I kill this with the exaggeration 1. But there was something like geology, wasn't it? This is quite easy. We go to the properties, and by now we take here the categorized geology, and the value should be, of course, our stratigraphy, and the symbol. No, this symbol is not the best. It should be a symbol without any circle around it, something like this. Okay, and perhaps a little bit smaller. No, it's okay, but we have to somewhere set the, okay, classify. And now I see my geology, yeah, but I have to take smaller symbols. Is it here? I should have taken here already smaller symbols. So size 4, no, it should be size 2 perhaps. Size 2. Okay. No, I say cancel. I go back. I do this again. So, categorized. The value is clear. The value is the stratigraphy. The symbol should be changed so that we don't have this circle around, but also with a very small symbol here. And I say OK. And by now I want to classify everything. Now I have small dots, but in color without an edge or a circle around it. I say apply, and I say OK, and I have it here. Yeah? I think that's nice. And now we can start constructing. For those who are working in northern Germany, it would be nice to have also not only the geology here at these points, but to have perhaps also boreholes. Yeah, and this is a little bit tricky. Of course, we get also boreholes here into this cross section, but it's a little bit tricky. But I think with this, this helps you already a lot. I hope so. For the geology as well as for. And now we can create, for instance, lines and set points on lines or export points from the lines, and then you can get XY coordinates back. This is a little bit. No, this is not easy. This is not easy. So digitizing based on this should be easy. It's a little bit bad that this color is this makes up the Banta, and this green color also makes up the middle Banta. Or is this, no, this is, oh, I have to inform myself. So this is here. Middle Banta, yeah, and this should be also middle Banta. Yeah. But this here is Mittlerer Buntsandstein, and this is SN. This is the same stratigraphical unit, but I made here this mistake that that this polygon got the wrong attribute here. Okay, so here this is already lower Banta, and this, but this should be also lower Banta. Why is there a different color? Okay. This is only these 2 points with the lower Banta. That's right. Here you have already quaternary. So you have here lower Banta, only these 2 points. But here you have the lower Banta, yeah, very widespread, going over big area. Yeah? Quite interesting to do something like this, yeah. Of course, based on this, you can now either add add some points to this. Yeah, this would help if you use. Oh no, you can also use lines. So if you digitize lines by now, no, sorry. If you digitize lines by now, create a line layer. So this is geol layer 1, and it should be a line here. Postcolor zone 3 and K. I don't know. It should be MU for the upper, for the lower middle Triassic, middle Triassic, yes. No, this is not necessary. Okay. So I can now digitize these. Where is it? Hey? Where is my layer? Away. Did I check cancel? No. CS points, cancel. No. Okay, CS line. CS line geol. Let's do it like this again. CS line geol. Should be line. Did I choose here perhaps the wrong zone? Okay. Now it's there. Okay. So I start digitizing. So I create here, for instance, some line. So this is line number 1. This is for the lower middle Triassic, and line number 2 is for what? I don't know. For the upper lower Triassic. And internet line 3, and so on. So then you can, with this, you can work by now. The problem is a little bit, this was another value by now, doesn't matter. The problem is a little bit that you have, of course, as attribute, or if you add, I don't know, we will convert this to points. This is quite easy, or not easy, but I want to generate points along. I want to generate points along line. Yeah, you have here in your toolbox vector creation tools, and one of these tools is generate points along line. Generate points, pixel centroids along a line is the tooltip here, and I take it may be that we didn't have to change to switch to GIS, that this works also here. No, we don't have a no. It doesn't do what I want. Random points along line. No, I want to have what's that? There was somewhere a method. You can convert the geometry type so that every vertex that you set here is converted to a point. This is also no problem here with convert geometry type. Oops. Lines to polygons. Points along geometry. There it is. Points along geometry. So there you can pick your lines and you say you want to have it in a distance not of 1 meter but of, let's say, let's pick these 25 meters from or let's set the 25 meters from our raster. The start offset should be 0 and all the other things, and we create points along this here. Run, close, and now you see it has automatically created these points. Yeah. The problem is a little bit that if you add XY coordinates to your points here, distance. Okay. Yeah. If you add XY coordinates via this field calculator here, then it's nice to have the exaggerated by 5 that you get the Z coordinates, but on the other hand, it's a little bit a problem that you get only the distance as X coordinate. Yeah. So creating a field. So X, a decimal number, and I want to get $X. Okay, so this is from the starting point of your cross-section. So this doesn't help you really. The Z coordinate, of course, this is the Y coordinate. Y, Z. Like this, perhaps we do it. This is quite easy to understand, but on the other hand, all this will be, of course, with the exaggeration of 5. This is clear. this is what we want in the end. This is most important. And with the field calculator, you can divide this once again. So you can create Z field with decimal, and you pick here fields and values. This one divided by 5 again, and then you get the correct height. Yeah, the correct height value. This is nice. But on the other hand, with x, we have a problem. Yeah, we have to convert x to y, to x and y, and this is a little bit tricky because in the end you have to compare this to your to the points up here. Yeah. So in the same distances, you should have, you see this point has the same distance as this point, as this point, and this point, and therefore you can derive also the xy coordinates because you have the xy coordinates of this point, for instance. So you can set this also to the others, but this is a little bit tricky. Yeah. Any questions about this? I think you are really happy and you have a good sleep this night because you know in future all your cross sections will be done digitally, and you can use this for setting up 3D models. We will see tomorrow how this works with the 3D models, with the 3D modeling, but you have cross sections here. Yeah? Of course, you can fill this also as a polygon with some lithology, with some symbols, and with the color of the stratigraphy here, or with the color of the hydrogeology, if this is aquifer, aquiclude, or whatever, what you know from your from Tuesday morning, and this is quite straightforward, but exporting this back to a map, it is a little bit tricky. Yeah. So I stop editing right now. Save and save. Okay. The interpolated points. They were a temporary layer. I don't know where I saved it by now. So I have to export this. It should be the cross section CS. Horizons. Let's make it like this. Okay. So to export this to get here at this point the XY coordinates on a map, this is not possible anymore. Yeah, it is not possible with the means of QGIS or of SagaGIS, because this is beyond the frame of the work of these two tools. Yeah. So we come now to the edge of working with GIS. We are now going beyond the range of GIS. And this leads to the point where we have to program ourselves if we want to have something like this. And this means we should have a break until 2:30. And then we continue with 15 minutes break. If you have questions, please prepare them to have these questions after the break. Yeah. But then we should at least get a first impression how to program in a GIS, so that you are not left alone with this topic too in this course. Okay, see you later. Same mistake as before. Muntes, not minutes. Okay, so back again. Short break and back again. So the question is, what can we do? First of all, have you got any questions about the topic in the afternoon, or even for the topic in the morning? Any questions? Okay, no questions. So then I would like to go beyond the normal or the available and ready to use procedures in GIS. You saw here already that we have a lot of toolboxes, that we have a lot of methods here in our toolboxes, and as I said, there is already a whole lot or there is already a lot in QGIS available, but some methods are only available in SagaGIS. And you remember that I said, okay, there is a lot of modeling already available, GIS modeling, not numerical modeling, but GIS modeling available. When I say modeling, be a little bit careful. All these methods that we have here, including the modeling, normally runs only on one single thread. So this is no high-end modeling tool here, such as GIS. It is more or less comparable to some things like Excel or something like this, which are also running on one thread, you know. And as far as I know, also these big tools here for geological modeling, GoCard, Petrel, Move, Andino, and all these things, they also only run on one thread. Normally this doesn't matter, because what we did by now runs fluently with one thread, but the problem arises when we go to numerical models. Then of course, if you iterate and so on, then you will have problems with run into problems with the iterations, with big data sets with a lot of memory and so on. Okay. With a lot of memory, it's no problem directly here in GIS, because the memory itself, it is available. If it's there, then if you have this main memory here big enough, then of course also big data sets of remote sensing data and so on are suitable to work with, or are ready to work with, even on actual or recent computers with big memory, but without any big CPU or something. Okay, so let's have a look at the possibilities to extend what we know by now and what we have, what is already programmed and predefined. I mentioned already that we have, additionally to these procedures and methods, that we have also the possibility to use plugins. Yeah, and if you look at the plugins, you will find a really big number. These plugins are not produced by the developers of QGIS or SagaGIS mainly, but these also there the community is not only one programmer or something, one who writes the code, and then everything else, or then this is published or something. But there are also working groups working on these GIS. But here these extensions, these plugins, as they are called, they can be programmed by anyone. Yeah. You can program, of course, also your programs on your own, your plugin on your own. No problem. The only question is if this gets into the official repository of plugins for QGIS. And we had, for instance, one MSc thesis some years ago about groundwater vulnerability. Yeah? Vulnerability, groundwater vulnerability. This is from Christian Böhnke, you see here. And this was a student who finished this, or who programmed this as his MSc thesis, and MSc thesis, not PhD. MSc thesis at the Free University, and I was one of the reviewers here, and he did it in QGIS 2 point something, I think 2.18 or something like this. And then after some years, QGIS 3 came up, and he nicely transferred from this tool from QGIS 2 to QGIS 3, and it is available right now. And he took care that it is also available in the repository of QGIS itself. I think he also worked on it, but I'm not sure about this. I didn't ask him later. That he worked at Fugro some time, and that means he came in connection with Geodin, of course, because Geodin is produced by Fugro, which is a company, as I mentioned, from the Netherlands, but with a big dependency in dependance in Berlin. And this, and during this time, I think he programmed also Geodin. No, it is not available in QGIS 3 anymore. He programmed a tool for QGIS to link Geodin to QGIS. Yeah, we saw this already. We can export tables and work with the tables and so on. Yeah, and perhaps it's a good idea for you to find out how to, for instance, insert boreholes into your cross-section. This is possible. By now you know, okay, we need the distance. This is most important, the distance from the beginning of the cross-section. And we should have taken there a cross-section from borehole to borehole. We made this mistake, but it doesn't matter. You can also project on the cross-section, it doesn't matter. You need the distance and you need the height. And the meters of our sea level. And if you have an exaggeration, you have to regard the exaggeration too. This is clear. But in the end, this is quite easy to organize, to program or to set here, and therefore it should be no big deal here to insert into this cross-section here also your boreholes. Yeah? Okay, so coming back to the plugins, you may also, for instance, write a plugin for these boreholes or whatever. Yeah, what is not available by now. Although we have some some geological tools. So boreholes, if you insert this here, I think you should have, yeah, oh no, these are my two. Okay, feature wheel, no, but there, yeah, it's this Mitfachten here. If you go to this, you see a tool set that makes QGIS an interface for editing, viewing hydrogeological observational data, drillings, water levels, seismic data, etc., stored in a SQLite database. That means, yeah, okay, there is an interface to another database, in this case a SQLite database, and yeah, let's try it. Not by now. You do it at home. You do it if you want to, and all these things. Geoscience, tools for geoscience and exploration. Yeah. Display drill hole sections, vector tools, raster tools, and so on. Send ideas and requests to, okay, someone, Rowley Hill. You can do this on your own. It is possible, especially with the new possibilities we have here in QGIS 3, it is made very easy to develop your own plugin, and we will see this by now. Yeah? Don't close this here. We go to the question, how can we create such a plugin? Yeah? And for this, two tools are very helpful. Two plugins. Yeah. And the first one is the plugin plugin creator. How was this called? Plugin builder. The plugin builder 3. This is a plugin that helps to create a plugin. And the second one that we need, a plugin reloader. Yeah. So I would suggest to install these two plugins here. In my case, of course, I have it. I did it already. I work with it quite often. I say close. And also install the plugin reloader. Because otherwise, the plugins are loaded as soon as you start your QGIS. And the problem is, it takes some time to start QGIS, and the more plugins you load, the longer it will take to load, to open QGIS. And this means don't install too many plugins. Yeah, this will you will not be happy about this. You can uninstall some things, and you can easily delete these plugins from your drive, but on your hard drive. But on the other hand, but be careful with installing. Install what you need, and yeah, from time to time, please have a look at this repository here, plugin repository, so that you see what is coming up, what is new, and I would be happy if you developed also a nice tool, for instance, for creating cross sections or whatever. It is all possible. Yeah? You can even open from a plugin a completely new QGIS and work with this QGIS, transfer the data back to the other QGIS, and all these things. You can do really a lot. So plugin builder and plugin reloader. The plugin reloader there I stopped. If you have to start QGIS again after just setting another comma or something in your plugin code, then it is sometimes very tedious. All these plugins are programmed in a programming language called Python. Yeah, Python is very common as a programming language. It is quite easy to learn, yeah, it is an interpreter language. That means there is a possibility also in QGIS directly to program without setting up a plugin, and then the procedure is going, or the whole program is run through by going line by line through the whole procedure. Yeah. So if you want to do something like this, this is also possible. Then you should just open here the Python console. Yeah, Python console. You get something like this. This is very uncomfortable. You can write here line by line down here, but it's more effective to use the editor here. And this is the editor for Python code. You will get also some syntax highlighting. You can save this here. You can run it whenever you want, and not only line by line. You can also write several lines and then run it, and all these things. Yeah. Therefore, I think this Python editor here is quite comfortable. But for a first trial, you can write here 3 plus 4 and enter this, and this will give 7. So quite or the normal usage of Python is also supported here. Yeah. So but normally especially here in QGIS, it is very important to use the features that QGIS has already, and this all can be used from these plugins and from this Python editor or from this Python console here. Yeah. Therefore, perhaps it's also a good idea first to try to work with Python within this Python console, especially with the editor, and then just copy and paste this to a plugin that you generate or that you set up when you have finished something, when you think, by now it's ready. And then it will not run. Yeah, in some cases it will run, but of course you have to import libraries and a lot of things to get this Python code that you program here, to get this running also in a plugin. Yeah. So this is the first step here, to perhaps, if you want to, the first step to Python programming in QGIS. But you may also, and therefore I will close this here, you may also directly switch to Python programming in the plugins. Yeah? And if you have installed your plugin builder, plugin builder 3, and the plugin reloader, then you can use this also to create your own plugin. You will see, okay, when I open plugins, then the plugin builder is installed. Yeah? This is the same as we saw it with what? With I don't know which one we installed before. Profile tool. Profile tool there is also there. Geologists, you should have a look for the plugins, what they do. So plugin builder is used to set up plugins, chips, and you can set up, for instance, a plugin named AAA. This will not be given to the developers of QGIS, of course. This is only on your computer, and only if you want to get it into the repository, you can write then to the developers or to the community and say, okay, I have a plugin. You can also sell it somehow in the internet, these plugins. I will show you how easy it is to install such a plugin, to copy it to another computer. It is done without any problems, and okay. I call it like this. It's no reasonable name or something. So author company, also like this, email address. I will not insert this here. Or I will do it so that you know it also for the future. If you have questions, I will give it also to you tomorrow. But if you have questions, please ask me also in the future via email. Wolfgang.gossel with double S, not with the we call it Rucksack S with the special S set, but with double S at geo.unihalle.de. Yeah. Oops, Halle. So this is my email address, and please also in the future, if you have questions, don't hesitate to contact me then. Okay, next, brief description. This is all saved afterwards in the plugin, but if you load your plugin, then this will be this about will be given in the explanation in the plugin repository there. Yeah? So this plugin is added to your repository on your computer. Yeah? It is not added to the general repository in the internet. Okay. Yeah, okay. At this point, you can also choose in which menu you want to put your plugin, and you see what is available there. Normally, I take the plugins. Then I know where I have to search for this and so on. So, okay, all these things. And this we can leave away. And yeah, this is quite interesting. Where is the directory of the plugins? Yeah, because it's very nice. One plugin, or each plugin that you load, is saved in this directory with the subdirectory with the name of this plugin. Yeah, so we created by now, or we are on the way to create a plugin called AAAA, and this is saved as a subfolder in this folder. The reason for this long path is that, of course, you or each of the users of a computer should have access to this plugin or to his or her own plugins, and therefore it is saved under users and then your name. Yeah, and then follows a long path Yeah, we can copy this path, but I will show it afterwards also again to you. So I don't change it, because you are not sure afterwards if another user of your plugin can also access a path like this. If he is allowed to set up a new path, for instance. And all the links between, for instance, the graphical user interface that you create and the nice methods that you create, perhaps different files and so on. All this is lost if you haven't got access to your to this folder, because this is somehow hard-coded. So I say generate, and we get a warning, and this warning is due to the fact that your graphical user interface that you create by installing a plugin or by creating here such a plugin, that the user interface has to be or compiled to a certain extent. The trick is, this warning doesn't matter, because a compiled test version is already created, and with this test version, you only have to delete the test in front of it, test underscore in front of it. With this, you can work directly, and therefore, this is just a warning. Please correct this here. Yeah? Okay. Nice. Okay. So, in general, your plugin is by now available in Manage and Install plugins. I think my plugin was, no, it was not AAA. It was something like D, isn't it? No, I have to restart. Of course, it's not there. I have to restart my QGIS, but I can try to. No, it doesn't work with a plugin reloader. Okay, I have to restart my. This we don't need anymore. I have to restart my QGIS. Okay, plugins. Now you see, it was AAA. Yeah, it is there, the plugin. Yeah, I get this description, which was nothing, really nothing. I check it, of course, and now it's installed. Yeah, I can use it. Close. The problem is if I want to work with it, it doesn't work. Oh, it's not there. What's that? Do I have to start again? Yeah, maybe. Python error. Okay. Python error because it doesn't find the AAA this plugin, because we didn't change anything. We didn't change this test in front, or we didn't change the graphical user interface, the compared graphical user interface here. So, okay, module not found. The module is not found. Yeah, please have in mind it is this x something dot resources. So by now we should go. Oh, we can I close this here? We should go to our Explorer. And we remember it was under C, users. In German this is Benutzer, but this is linked to the users directory. and then my name, and then app data. If this is not there, please set here in the top line, click in the top line here, and insert the backslash and app data. And then you have roaming, and then you choose QGIS, QGIS 3, profiles default, and then we choose Python. Of course, then plugins, this is clear. And then we have this, this folder is by now, there I made a mistake. This folder is now called XCV, something like this, yeah? And you see, this, or the expression you wanted to load, or this file where the error message comes. So we go back to the error message. No, this is something .resources. This is missing. This module named is missing. Okay, we should have a closer look by now at our new plugin folder, and in test you will find test something dialog test resources.py. Test _ resources.py, and this you just copy, Control C to your to the upper folder, insert it there, and then you kill the test underscore. You delete test underscore. Then you have a resources.py, and this is already enough. So I will now restart my QGIS, and now I don't get an error message. You see, and I can run by now my plugin named AAAA, and you see, nice! I have already a graphical user interface. Yeah. Of course, there is nothing in it. There is only an OK and a cancel button. Yeah. But it has already something to close, and it has a name a little bit, and okay, it runs. Yeah. The nice thing is you can change this graphical user interface is built in Qt, written Qt. So this Qt is a library for developing graphical user interfaces, and mostly this is used by programming language called C++, but it is available also for Python. Yeah, this is then called PyQt. No? And this is a very well-developed tool and a very good toolkit, perhaps let's call it like this. And you can work with this with your graphical user interface that you just created with the plugin builder here. You can work with this graphical user interface in a tool called Qt Designer. Yeah, you get this directly with QGIS, everything integrated. You don't have any problems with this. You'll find this in your QGIS folder. In this case, QGIS 318. There you'll find the Qt Designer. Yeah? call this, I say I want to close this here, and by now I can open. I think you have it in English. I hope so. I have it in German. I'm sorry for this. You can open, of course, in this long directory. Users, your name, your username, app data, roaming, QGIS, QGIS 3, profiles, default, Python, plugins. There I have to look for this XC something. And there you see in your folder of the plugin, you see this this file .ui, yeah? User interface. So this is the user interface for your plugin, and you can work on this with the Qt Designer. I open this. Yeah, this is what I expected. There was nothing in it. But by now you can, for instance, drag and drop new push buttons, new combo boxes, new line edits, or whatever you want. Of course, you have to give them names, object names. You have to work with the data. This I will not explain today, but I just wanted to show you, you have the possibility to do this. Then you save this, and now comes the hour or the point where you can use the reloader, yeah, plugins reloader. The plugin reloader has to be configured for your new plugin, yeah. Therefore, plugin reloader configure. And I want to select, or I select by now the plugin I want to reload. In this case, it is this XC something. Yeah, okay. And when I now pick the plugin reloader, then it will reload the plugin XCVB or something. Yeah. It takes some time. You see this here, but then it is updated, and as if I run my plugin AAA by now, then I see, yes, the changes I made, the push button and so on, everything is there. Yeah? Okay. So this is already quite nice, but this is only the graphical user interface. The functionality is not there. Yeah, and I'll show you also by now the functionality, but I first of all have a look for your questions. Have you got any questions? Okay, you don't have any questions. I see this. You are all asleep already in India, and the others are having a big corona theater, and I'm here alone on this channel. No. Okay, so let's have a look at the point where you can program something. Yeah. So I go back to my directory. I hope you didn't close it because it's so long. Yeah, I just leave it here. So C, users, your name, app data, roaming, QGIS, QGIS 3, profiles, default, Python, plugins, and then to the folder where you have saved your plugin or the name of your plugin. And the point where you can program is in your folder name, so plugin folder name, .py. Yeah, not resources.py, not with a dialog or dialog base.ui or something. Only this name .py. And this file you can open with any editor. I would recommend Notepad, Notepad++, because you have there, on the one hand, the syntax highlighting, you have this indentation correctly, and all this done. This is done correctly in the way Python likes it, and then you will get less error messages. Especially with the indentation, I think this is not the best way, but it's a way to do it. I'm more working with other programming languages, especially C++, and for me this is quite unusual. I always make brackets around it and not indentation. I also indent, but yeah, okay, doesn't matter. So this is the point where we can program. Python, nevertheless, is a very good programming language, and the advantage of having an interpreter language is quite good. So I opened this with Notepad++, and you see a lot of code is already written by the plugin Builder 3D, plugin Builder 3. Yeah. From time to time, have a look at this code, or get used to this code and work with this. The only thing I wanted to show to you today, and then we will finish up also for today, is the point where you can start programming, and this is down here. If result, do something, this is a comment, of course, do something useful here. Delete the line containing path and substitute with your code. This is exactly the point where you can start programming. Huh? Of course, if you want to get some values, for instance, from the user, from some line that the user writes, of some words, or if the user picks something from the combo box or something, then also at other points of the program, of this predefined program, some code is necessary. You may sometimes want to program some sub-program. This is always done with def. Of course, not def init GUI, because this is the initiation of the graphical user interface, or you should not overwrite unload or put a lot of code into the unload procedure here, but you can write also your own sub-program or your own method here and do things. I will upload by now 2 examples that are going into the direction of cross-section, but they don't work. They are not finished. This is just the beginning of some of some programming in the direction of cross-section generation, and then 3D modeling in QGIS, and I will upload this, and I can show this also to you what is ready by now and how this all looks like. So it is on the one hand the I will start with this here, method or program, a plugin, to first of all load the raster data set, just as we did it before, the geology and boreholes, to create cross-section line. Yeah? This is the first thing I did, but I'm not ready here. So you can perhaps call the Saga methods via this via this call here. But in my case, this doesn't run, so I have to substitute it by my own code. What I did with, what we did by now with Saga. Yeah? So create points and pick the values from the raster and so on. This you either can use within Saga GIS, but on the other hand, but then the parameters have to fit very well. But on the other hand, you can also program it something like the Saga procedure on your own. The other thing that I started is also given or very obvious. If I create something or if I work within the cross-section view, then I have to export afterwards the lines. Yeah, we created the points on the lines already, but we have to export this again. And this is here. These are here the first steps to get this running. Yeah, so that you know what these plugins are for. And on the other hand, yeah, you can see, okay, this is a combo box here with the input points. This combo box is cleared by now. That means all the entries that are remaining from some other program call, everything is killed, and we start here, or the user gets a fresh combo box. And then into this combo box, yeah, some items are added. And these items are in a list of layers, and I get this list of layers in this way here. Yeah, I get them from my table of contents in QGIS. Yeah, it is picked already, or all the names of the layers that are available there. All the layers or the names are picked and put into a list, and this list is then inserted into the combo box, so that the user afterwards can pick which layer is, for instance, for input points or for the boreholes. Yeah. So I will show you the functionality after in a few minutes. Okay, so this is the background here of these two plugins that I will upload for download for you if you want to, and I will show what they do. Let's take the first one. So this is GIS to geology modeler, or to geological modeling. Oh, cluster. I didn't load anything. So to do this correctly, to work with this correctly, does this work? Yeah, it does work. I think so. I prepared a project. So you first have to pick point data so that the cross-section line is created. So before you start this program, this plugin, you have, this is quite strange, but this is how most of these plugins work. Yeah, that you just program a plugin for your own, and if it is working correctly and you are content with this, then you may publish this also. Yeah. So I picked here some boreholes, and now I can start with my plugin. So GIS to geological modeling. This will run by now. So I see here by now the X and Y values of my boreholes. I see the names of my boreholes. I can push them around and sort them as I want. And I can open the combo boxes here and I see all the layers that are here in the table of contents. I can set something. I can pick also or open the file selector here to, for instance, save a new shapefile. So it's also no big problem to save shapefiles completely with attribute table and everything you want. Yeah, so but the tool doesn't do more. Yeah, it's on the level of having this graphical user interface and the it's the borehole lines. I will save this once because the shapefile of the I will not do this. The shapefile for the cross-section line is also saved here with this tool, yeah. So that you can continue, you save this and you can continue then with Saga GIS. Yeah, as I've shown you, these were the last two lines here in my plugin. Yeah. Okay. Of course, it doesn't find the file by now because I didn't insert something. So this was the first one. The other plugin looks like this, but there also the functionality is not given. Yeah. Okay. Yeah. So that you know what is done here and how you can work with this. Perhaps if you want to do something with this. But the main thing is that you read the code, look into the code and see, okay, if I want to have a layer list here of this table of contents, then I do it like this. Yeah? I can easily do it like this. And if I want to fill a combo box with this, I do it like this. I have to get some variable, define some variable somewhere else. And yeah, I have to perhaps also insert a new function and these things. Yeah. And this is nice for all of the plugins. Yeah, you can look into all of the plugins and see the code. Yeah, you can analyze the code and see, this guy does it this way. This one does it another way. Yeah, and yeah, boreholes maybe saved like this and in a database, and I get the connection to the SQLite database via this Mid-button plugin. Yeah, I get an idea how to connect to a SQLite database. Yeah, so quite interesting to learn from these plugins, to create your own plugins, to extend QGIS as you want. This is the main thing here. Okay. Any questions about this? We can prepare also some questions. In the meantime, when I upload by now the this when I upload the files, the zip file with GIS to geological modeling and so on. Why do I have this? No. Okay. is that? Backlog found. What's that? Okay, I have to look. No. Why does it not work? Hmm. No, no, no. I have to look for this if this is on. And this should work. No. Hmm. Let's have a look. No, it works by now. No, it doesn't work. Why not? Um, I don't know what the problem is. But zip files are not a problem. No. I have to give it to you tomorrow in the morning. I'm sorry for this, but I don't find the reason why I can't upload zip files, PDF files, or no, it doesn't upload anything at the moment. The PDF file in the morning, it worked, of course, but by now I can't upload anything. So I'm sorry for this. No, I'm sorry for this.
Maybe try the private email provider, because the universities sometimes block a few things. For example, you can't send old .doc documents. You can't send them to university.
I can send it to someone of you. This is perhaps I can also.
No, I mean from the private account. Die Universitätsprovider haben meistens recht viele Formate blockiert. Kann
ja,
sein,
aber
daran liegt, dass die gar keinen ZIP annehmen.
Ja, das hatte ich jetzt gerade auch gedacht, aber das Interessante ist, dass ich ja bis gestern ohne Probleme ZIP-Dateien hochladen konnte, dass er mir auch ZIP-Dateien anzeigt und also aus anderen Lehrveranstaltungen, wo ich das auch schon so gemacht habe, dass es bisher nie ein Problem war. Und zum zweiten Mal, ich habe jetzt auch versucht, eine PDF hochzuladen und auch das geht nicht. Und das irritiert mich halt sehr. Das irritiert mich halt sehr.
Ja gut, dann habe ich auch keine Lösung, Entschuldigung.
Ja, eben, das ist sehr seltsam. Kann ich denn überhaupt noch einen Ordner anlegen? Ja, das funktioniert noch. Aber ich kann ihn auch nicht mehr löschen. Nee, ich kann auch keinen Ordner mehr anlegen. Nee, also es scheint, so there seems to be a real big problem in the system. On the one hand, I can try to upload this on the server of the Free University. This would be one possibility, but another possibility would be, of course, tomorrow. This problem should be solved. So tomorrow I can give you this zip file. Also, another possibility would be to send it to someone of you to upload it somewhere, for instance, to Brinda Katekian. So there are a lot of ways what we can do by now. Or Mrs. Schmidt. Yeah. Okay. I have your account or your email address. This is clear. So I will send it to Isabel Schmidt and she will distribute it. Yeah. This should be no big problem. This I can do in a few minutes. Isabel Schmidt. So, ich mache es ohne Kommentar. Nur mit dem Anhang und mit einem Betreff. Oops. So, use this. So it should be sent to Isabel Schmidt. Yeah. Okay. So I don't see any more questions. I hope that this, on the one hand, the additional raster data handling from this morning and from the early afternoon by now, and especially this Python programming and plugin programming, that this helps you in future. And as I said, the first, what I would like you to do is, if you have questions, send it tomorrow in the morning for the morning session here via the chat. Prepare this a little bit for your cases, for your questions, and on the other hand, yeah. We see us tomorrow in the morning with the preview, what is going on, how the development goes on. Yeah, I think we have there also some time for questions. This should be, or some more time for questions if you have some. The other thing, of course, as you have seen. There is the possibility, or as I've said, there is the possibility to ask me via my email address, via my email, and this will be also, this you can ask also in the future. Don't use it for some advertisements or something. Don't do it, please. Okay.
Can I ask a quick question?
Yeah.
Is there an exam planned for tomorrow?
Yeah, an exam plan is there. Okay, that's right. I would suggest to have the exam at starting at. Is it suitable at 1 o'clock? No, this is too late already. At perhaps 12 o'clock. Perhaps this is a good compromise. Do we get this? Yeah, we get this. At 12 o'clock to start, you will get all the material you need. You can, or you have to work on this material, of course, but on the other hand, you can use everything you have. You can, and you should work also in groups to get this this problem that I will send to you to get this solved. And you can use also the internet for the questions to solve the problems and so on. Yeah. Of course, it will be a problem, not so technical. It will be no big technical problem. It will be more a hydrogeological problem. Yeah, not. I don't want to test your knowledge about technology or techniques that we learned here. Of course, you need it. It is clear, but more the hydrogeology. Yeah, and then you have to send it back until a certain time. Normally this is 2 hours, so you send it back at 2 o'clock tomorrow. But I'm not so very strict with this. Yeah, I can say this already in advance. Yeah, so this will be
that would be interesting to know, because that's right around lunchtime as well. So I guess we'll do a break from 11 to 12 and then exam time, or?
Sorry, once again?
Because it's right about lunch, and if it takes longer than 2 hours, maybe 4 hours, maybe it's a tricky time to start at noon, no?
Okay, then, yeah, okay, if it's not, if you want to have lunchtime, yeah, then we should start at 1 o'clock, yeah? 1 o'clock, that means 5:30 in India, yeah? Okay, 1 o'clock, we will start then. And then, of course, 2 hours until 3 o'clock. Yeah. So, Mr. Schmidt. Right. I did not get the mail yet. Oh. Oh. I sent it. Perhaps there is something, yeah, from my side, it's gone. Perhaps something, perhaps we have some problems, some severe problems with our IT here in general. This I don't know. I receive emails at the moment. This I control, but it may be that it takes a little bit of time for the transfer. But it may be also that we have a general problem here in the IT in Halle. I just try again to upload the zip file. No. I only get error messages. If I want to delete something from my folder, from the folder, if I want to insert something, a new folder or something, and zip file. Perhaps it's, we have to solve it tomorrow. Yeah. Okay. So, with this bad experience, I think there was a lot that you have seen today, a lot new things, I think, and I hope you take the best advantage from this, and you make the most out of it. And as I said, I'm open for some or for any kind of collaboration in this field of programming, especially if you have an idea and you want to do something. Yeah, you can get support from me. Of course, I will not write the program for you. This is clear. But if you have one or the other questions, I'm here and I try to answer these questions. And on the other hand, if it's going beyond this, please also feel free to ask me for support or for some review or whatever. Okay. So, for today, bye-bye. See you tomorrow. As I said, tomorrow will be a little bit of perspectives. Where is the train of hydrogeological mapping going? What are the new things that shine up by now? And on the other hand, by now mail delivery system is sending me a message. Interesting. Yeah, we have a problem with the whole system. So, of course, Isabel Schmidt at fu-berlin.de, fu-berlin.de ist richtig. So, it's this email address is correct, isn't it? Oder ist richtig, ja? Okay, then we have a problem here with the IT in general, not only with the cloud, but also with the email server and the email transfer in general. Although I receive at the moment emails, but obviously I cannot send any emails. Sorry for this. We will continue with this tomorrow. Yeah, I will upload this for tomorrow and send you the link as usual. Okay, so. Have a good night, have a good evening, have a good afternoon, whatever. Hope to see you here in this pool, in this sessions tomorrow in the morning and tomorrow around lunchtime. And I'm not sure if I, eine Frage an Frau Schmidt und Frau Kartikeyan. Wie ist es geplant mit den Exams, mit den Klausuren für die indischen Teilnehmerinnen? Können Sie mir was sagen? Sie können ja ruhig ein Mikro nehmen. Werden die teilnehmen oder eher nicht? Oder ist das nicht geplant? Ah, das Mikro funktioniert nicht. Okay. Ui. Ich werde es zwar auf jeden Fall so machen, dass ich die Fragen auf Englisch stelle, das ist keine Frage. Ja, das wäre ganz gut. Das wäre sehr nett. Ich stelle auch gerne Scheine aus. Das heißt, das ist übertrieben. Bisher hat es immer Andreas Winkler gemacht, die Scheine auszustellen, auch für die deutschen Teilnehmerinnen in den letzten Jahren. Und Michael Schneider. Da musste ich also gucken, dass dass von einem von den beiden das jeweils unterschrieben wird. Gut, alles klar erstmal. Danke, bis morgen. Tschüss.